1500 is going to be like for how many firsts you have. Hey, Eldritch. Yeah. Hope you're all doing well. I'm just getting things set up. Let me hop in the Discord. It's another reading group day. What problem did we leave off on? That problem 10 looks familiar. Problem 11 looks familiar. Hey, Hayden. I entered home and see you live. Hell yeah. Oh gosh, okay. Let's get number 15 in here. I don't know how it's gonna work. But to be fair, that can be said for nearly all of these problems. Now, I also haven't used Excalibur with this tablet that I just got this week. Well, how did I set up these hotkeys? This button does writing. That button does panning. That button does selecting. What does that button do? Nothing? I swear. Oh, I think. Ooh, no. Okay. Thanks for saying hi, Hayden. I appreciate it. Hope you have a good day. Let me. Okay, wait. That button is rating. This button is selecting. Is that button delete? It is. Okay. The bottom two, zooming. What? Okay. Those are just the default. Okay.
Good afternoon.
Benbox, hey. How's your day going?
Good day, lazy day. No physics yet, so
Nice.
hopefully I'll remember some things.
I'm feeling the same to be honest. I've been so deep in the mechanics, and then I'm nearly through reading chapter 7, so I think I've forgotten a lot of chapter 6.
Chapter 7, wow.
We're getting up there. Consider an infinite straight wire carrying current I. We know the magnetic field outside the wire as B equals mu naught I over 2 pi r theta hat. Oh gosh. There are no currents outside the wire, so del cross B is 0. Right, that's by explicitly calculating the curl. Okay. Wait. Are they saying the curl of a magnetic field is 0? That feels wrong. I could go through, like, we could go through this calculation, but I don't know what they're saying this is.
Yeah, that's what that is, the curl, del cross B.
Because those magnetic fields literally just go in a circle. That should be, I mean, I assume that's the most curl you can have. I don't know exactly how curl works, though. I'm trying to find the curl for... They give us the theta hat vector, so I assume we want cylindrical. Okay. Found it. Okay. Oh gosh. Thickness. There we go. So we have that these mu naught I over 2 pi r theta hat.
Oh, you got the tablet going. Nice.
Yeah, it's for some reason with Excalibur, but so I got used to like how I set up the keys for this thing, but yeah. Um,
How do you like that Journal plus plus thing? I saw you using that the other day.
uh, it's not bad. I haven't tried anything else to compare it to unless you want to count Paint. But it's like free and open source, and I want to see
Yeah.
if I can write a plugin for it, or like potentially multiple, and you can do that with that. So so this thing is only varying with R, right? So those two partials don't mean anything. That partial doesn't mean anything, and that partial doesn't mean anything.
I think AZ is 0, isn't it?
Uh
Or BZ in this case, because we're doing del cross B.
oh, yeah, I forgot. It's the Z component. Oh my gosh, yeah. That's confusing because I mostly use like the subscript like f sub x is the partial with respect to x. I was getting confused on that. But yeah, that's a good point. Oh god. Oh no. Like that. Okay. Well, that makes it even simpler.
Yeah, if we multiply by R, we get a constant.
Right. You not. Oh yeah, yeah. Okay, I see it. 2 pi r. Oh, I forgot to actually write the derivative part, didn't I? So yeah, that does just go to 0, as you say. Okay. This feels weird to me that the curl of this thing is apparently 0. There are no currents outside the wire. I wonder why that's the reason there's 0 curl. Is there only curl inside the wire? Like where the current is then?
Maybe.
Hmm.
Yeah, I still get confused by curl.
Yeah. I
You'd think if the whole field looks like a bunch of concentric circles that's curly, but
yeah. I think that divgrad curl and all that book that you mentioned might be a good reading group idea because it's short
yeah.
and it could be fun.
Yeah, I got through about two-thirds of it, maybe three-quarters of it. I
Okay.
didn't do any of the exercises, but I read along with the chapters and it was really good.
Okay.
I wish it had sunk into my head a little better.
Yeah, I mean, it would be helpful for like this. Okay, so since
This book was talking about the same kind of thing way back in the first few chapters, wasn't it? I think it was like chapter 2 when they did
yeah,
the divergence and the curl.
yeah, that's when
And
they introduced curl like as a prep for this part. I think like we hardly even use it in
that's
chapter 2.
right. That's right. That's right. They didn't really have to use it.
Hey, Mean Machine Rex. The curl can be written as a cross product. This is often how it's abbreviated. Yeah, it's the gradient crossed with the vector field, essentially.
Curl cross divergence dot. Good way to remember it.
Oh, neat. You know, I'm just thinking now about what this. Maybe this is like probably way too off topic, but like what the del cross B actually measures. It measures how much the field is pointing in the direction of steepest descent, I guess. But in somehow that gives you its tendency to curl around. I don't know. Maybe I shouldn't go there right now.
What about if we went to if we went back to like cylindrical coordinates, or even rectangular coordinates? I'm not suggesting but what I'm thinking about is if you have a circle, right? So x squared plus y squared equals r squared.
Mm-hmm.
Then the tangent line, so if you sort of define it parametrically to go counterclockwise, yeah, like let's say we had the unit circle, right? So unit circle, oops, radius 1. So if I had a point there, point xy, then the tangent would be going at right angles, wouldn't it?
Yeah.
So how does that work? You say like r equals xy.
Oh yes. Cross product is
V equals,
more when they're perpendicular. That's right.
I think the v is minus y comma x. Is that right? If I'm thinking like x squared plus y squared equals 1
Yeah,
in
for
this case.
perpendicular.
So if we've got that, what's the curl?
Oh,
What's
is
the
it
curl of that
minus x?
velocity?
No, it shouldn't be. Sorry, what's the curl of that?
So I'm thinking the v field could be minus y I hat plus x j hat. So what would be the curl of this? I'm just interested because I think it sort of feels like that's what the kind of question we're looking at.
Yeah.
So what's the curl? So let's see.
Isn't the
Curl v.
gradient 0 though?
I'm not even saying this is related to, or I'm just trying to think of how the curl works for this kind of circular motion,
Okay, yeah.
just for a second. So ijk. So how does this work? It's partial derivatives, right?
Yeah, but then we're doing the partial, or like, I think for V, we're going to end up with things that are zeroing out.
Yeah, this should come out pretty simply.
Oh, I forgot it's, okay, I forgot. That's not the gradient of V, it's just like the derivative operators. Okay.
So what do we get here? We get, oh yeah, we get 0, 0, yeah, 0, 0, but something into k, right? So I just get 2. Oh, okay. So it's 2. So see, that's not 0, is it? Right. So that field is kind of like a whirlpool going clockwise around the origin, right? And
Right.
it's not a 0 curl. So isn't that, yeah, I'm confused now because I thought the magnetic field around a
Oh,
straight wire.
we just did the same thing, yeah.
Yeah, I thought the magnetic field around a wire was this kind of field, like a,
Yeah.
oh,
That,
is it because, no. I mean, in order to really make it a magnetic field, we'd have to have the decreasing magnitude as we go away from the origin, right? But that shouldn't change the fact that the curl's not, it doesn't feel like the curl should be 0. I don't get this. I don't get it.
sorry, just a quick note for syntax error. I did put some math chat, but you have to scroll up a little bit in it because there are a few chats after that. But yeah, Like we just showed it, so I guess it's true. But this is like, I wonder if the answer is going to explain it more. I don't want to look at it yet, I guess, until we look at part B. But this is kind of confusing.
Yeah, well, I guess let's just move on to B.
There are no currents. It's, yeah, no, I'm trying to justify it, but I still can't. And hey, Viv, yeah, we're looking at vectors just in connection to this like magnetic field, and we're kind of confused about it, but hopefully we can figure it out. So we have to find a potential function. This is like pretty common like multivariable calculus type question, right? Like we know that something is the gradient of this other function psi. And so the gradient of psi is equal to, I guess we're doing cylindrical, so psi sub r hat plus psi sub theta hat plus psi sub. Actually, I don't remember how you even. Or I remember like kind of how you do these, but what?
I'm just looking up the formula for gradient and cylindrical.
Oh yeah, it's not as simple as I wrote it. The gradient. Oh, okay, yeah. There's a couple of coefficients here. Good catch. I just pasted it in. Oh, that's a terrible screenshot. Get a better one. There we go.
So we need that middle term to be mu naught I over 2 pi r, right?
It's looking like it. So like,
Yeah, I'm
like
thinking this one here. We
b
want to
sub
get
r
this to
equals
be
0 versus psi. Yeah, I agree. And then is equal to actually I should write it with like the actual like d psi d theta. So mu naught I over 2 pi r. I guess theta hat, but that doesn't matter as much. 1 over r times that.
Yeah. Couldn't we just cancel the r's and make it constant?
That seems like a thing that we could do. Yeah, actually, and that would, well, I guess so, yeah, because we're integrating with respect to theta. So
Yeah.
we're thinking mu naught I over 2 pi theta.
Yeah.
Theta hat?
Well, no, because it's
No? Oh, because we already have those
it's
written
a
in.
scalar, right? Yeah.
Oh, you're right. Yeah, we do expect a scalar.
I
I
don't
guess
see why
so.
that wouldn't work.
Yeah, that feels too simple, but like it seems
So what's
right.
that? So it's a constant times theta.
And we're supposed to explain why this thing, the usefulness is limited as a potential function.
Well, how would that even make sense? If you go around a circle from 0 to 2 pi, it feels like you get a
Hmm.
discontinuity.
I mean, I
If you plug in theta equals 0, you get 0. But if you plug in theta equals 2 pi, you get mu naught I.
you get I.
It feels
Um,
kind of like that complex logarithm function where when you swing around through one revolution, you've kind of gone up.
well, how's it an actual discontinuity?
Well, because if I take the limit as theta goes to 0, I get 0, right? But if I take the limit as theta goes to 2 pi, I get mu naught I. But then if I think of a circle, I mean, the theta is 0 and the theta is 2 pi are almost touching each other, right? If I go out along the
Oh,
x-axis.
um,
Is that right, or am I thinking of this wrong?
I think that's the wrong interpretation. I think, at least how I'm thinking about it, is that
Oh, no, wait, you're right.
it's
That's
about
that's not
work
how it
done,
works.
right? So if you go one full revolution, like this is saying it's like you're doing work, but I think you're not actually. And I think that maybe that's the point. Because I'm trying to think like when we were doing electrostatics and we had a point charge, I should draw the arrows the other way. Like the potential there was the work you did to bring another test charge in from infinity or wherever.
Right.
And so we kind of like opposed the field of a positive charge. But if we go along, and so I think the 2 pi would represent doing one revolution around this magnetic field line. And that's why
Yeah,
a different
okay.
value is okay. But that can't be work because it's perpendicular, the magnetic field is perpendicular to the actual force. Because F equals QV cross B. So if you go along the vector field, you're always like you're never opposing the actual force. I assume that's why the usefulness is limited. Like this isn't actually work. But that kind of makes sense. Where
I
like if
think
you, oh sorry, what?
I got to think more about what a magnetic field means. Like, what does a magnetic field line mean? In fact,
It's weird.
yeah, you know that physics and depression. I don't know if you noticed last night he was on at like midnight. I didn't stay up to watch it because it was kind of late, but he was reading a paper, and the paper was a recent paper, and it was talking about how something to do with the fact that all the textbooks that say that magnetic field lines have to be closed have got it wrong.
Oh,
And
hmm.
and I don't really know why. I didn't follow all of what he was doing because like I said, it was kind of late and I didn't watch everything he was doing. But I mean, I understand an electric field line. An electric field line tells me if I put down a point charge here and I set it down here, then it's going to accelerate in the direction of the electric field line. But what the heck does a magnetic field line tell me? What does that tell me? I know it
It
tells me if the charge is moving, at right angles to it, then it'll give me a force on the charge, right?
um
By
yes.
this F equals QVB.
I felt that same question, and I think how the book has defined it, or at least how I'm explaining in my head, is like through this relativity stuff, the book has figured out what the F is, like what the total force is, by getting the total electromagnetic the total electric force in one frame and translating it into a frame where the magnetic force is relevant. And then this B field is whatever it has to be to get you the right answer for F. And so that's why it has this weird, like, not one-to-one correlation with how the force actually happens. Like, they just found, like, the total force in one frame and know what the total force should be in another frame, so you can work out what B must be. But it's really weird. I don't feel like I fully understand it myself.
It is weird. So the name of this question is magnetic scalar potential, with potential in scare quotes.
Yeah. In this theta, not parameter, but the theta variable that we have in our psi function, I interpret it as like you choose some starting point on this field line,
Yeah.
and you either you follow it or you oppose it, but either way you go in a circle, and you can measure how many, like, I mean, I don't really know what it's measuring, but you could do as many revolutions around it as you want, and if the B field was exactly like force, you would get work.
Right.
But since it's not, you don't. I don't know what you do get, but
Yeah, because if that was, you know, an electric field line somehow going around in that loop, then if we moved a test charge around that loop, like you said, if we moved it in the direction of the loop, then the electric field would be doing work on the charge, or, you know, we'd be doing work against the field. But in this case, if you move the charge around that loop, it's not gonna have a magnetic force, is it? Because at every instant you're kind of going with the B field. You're not going
exactly.
so the cross product would be zero.
Mm-hmm.
Okay.
Um, we'll welcome in Parasrana. This is a reading group I've been doing on every Saturday, so I'm going to call with Fembox fan, and we're just working out some E&M problems. This normally happens for about 2 hours total, and then we do just like a normal math help. Hey, Phobos, are we in a conservative vector field? I think fields stop being conservative when you have moving charges. Oh, well,
I don't know.
in chapter 7, they definitely start saying that these fields aren't conservative. Like, they make a point about that. It might. Oh, I don't know if this is conservative. I don't remember if that was for magnetic field, like, or like for the B field that we're talking about, though. It might be, I've been talking about it for something else. Work done since B is always perpendicular to F. And I assume that's what they want for part B there. Parsing, I'm about to click away from it, but it's basically we're learning about the magnetic field in this chapter, and they're giving a hypothetical thing that you could take for magnetic scalar potential, like the potential difference for electrostatics, but we're saying why this version of it isn't particularly helpful.
Was this the chapter where they talked about a vector potential?
Yes.
I feel like that was the A vector, wasn't it?
Mm-hmm.
Okay. So that was a vector potential. Now they're trying to look at a scalar potential.
Yeah. So I think I'm ready to look at the answer, but do you have anything else before I do that?
No, I'm puzzled by the whole thing.
Yeah.
So
I
it's
mean,
fine.
I feel like I'm good with part B. Part A is like, I think we're getting the right answer, but I don't really know what that means. 15.
I mean, it really only was a line or two to show that the curl was 0.
Yeah.
I feel like that was right. I just don't understand why.
Mm-hmm. Well, they're not really explaining the part that we're confused on, are they? Oh wait, they're looking at the same exact like example curl vector that you brought up with minus y and x and 0.
Okay, then what did they
What
what did
the?
they do? Oh, okay. So they brought it back to in terms of B, right? I was just thinking of
Oh,
a velocity field or something.
okay.
And they did scale it by x squared plus y squared, right? That's what I was thinking. Like the one I was doing didn't take into account the fact that as you go further from the origin, it has to fall away like 1 over r or whatever. What did they say? The only component of the curl that has a chance of being non-zero is the z component. You can quickly check that this equals 0. You know, that's the reason I wrote this down, is because I wanted to think about that. Oh, so if
Yeah,
I'd
like
put those, oh, Don, I get it. If I'd put those over x squared plus y squared, right? Because I see I didn't put sine and cosine theta. I was trying to think of x squared plus y squared equals 1 for the unit circle. But I guess as you go in or out, I would have had to take into account that. So maybe the curl's only 2 when you don't take into account the fact that you have to scale it by the distance from the origin. Okay.
wait. So you're saying if we made your v vector a unit vector, this would have worked?
Yeah, can I try it real quick? Let me
Yeah,
try it.
because I want to
So
see
I'd have to,
this.
yeah, so I'd have to divide it by, so I want to divide by the magnitude, right? Which is the square root of x squared plus b squared,
Yeah.
x squared plus y squared. So I'm going to put this over square root x squared plus y squared. So over square root x squared plus y squared. Unfortunately, it makes the derivatives messier, doesn't it?
Oh, true. But I kind of want to see it. I feel like it's worth doing.
Yeah. You know, I feel like this is something I've done in my math history like 100 times, but I don't know why I just don't know this already. Okay, let's fix it. So that shouldn't change the first two components for sure.
Right.
So what's partial dx of x over square root x squared plus y squared? Do I really have to use a quotient rule for all this rubbish?
I guess so. That's annoying.
All right.
Low D high minus high D
So
low.
yeah, so it's gonna be bottom derivative top minus top. What's derivative bottom? Times 2x, right? That's that. And then minus the same thing for the, did I just go the wrong way? Partial dx. No, I went the right
No, I
way.
like that.
Partial dx,
Yeah.
and now it'll be plus, because I got a minus y there.
Right.
Partial dy. My handwriting's not very good here.
I think it looks good.
Is it? Well, thank you.
Yeah.
I'm much better with a pencil and paper. I can.
Yeah.
One.
Nothing beats that feel.
It's going to be the same looking
Oh, we do
thing
need
here,
our
isn't it?
denominators here, don't we? We're gonna add that on the end.
Yeah, I was going to bring
Okay.
that on times. There's 2y. So all the twos cancel, don't they?
Mm-hmm.
So if I just get a common denominator, I get x squared plus y squared
Oh, wait, but the entire thing is
minus
over
x
the bottom
squared.
squared. Like it should be
Oh,
like,
the whole thing. Yeah, gotcha.
yeah.
Sorry. The whole thing is over the bottom squared. So then I'm going to do x squared plus y squared minus x squared plus. So that all comes from the first garbage plus x squared plus y squared minus y squared. I've got a mistake, haven't I?
I think it's
I've got a mistake.
uh like I think that needs a root. We're getting common denominator. No, it doesn't. It doesn't.
I want to put this over the whole thing to the 3/2 power, maybe.
Yeah.
2x squared, 2y squared. This is all supposed to cancel. I'm missing a 2. I screwed up the 2 somehow. 1/2 this to the 2x. The 2's canceled though. Yeah, I'm going too quick here.
What are we?
I think I was okay up to this point, but I'm going too quickly here.
Think about AI solving this for us? Like that'll be no fun and probably wrong.
So we're going to say this is x squared plus y squared minus x squared, isn't it? Oh, -1. Sorry. Wait, I see it. I see it. No, because I took that minus into account. I think I got a negative I've missed somewhere.
Um, hey Scorpio.
So it equals 2 root x squared plus y squared. Let's not do it the way I was trying to do it. I was trying to group the first 2 terms and the last 2 terms, but let me group the first term and the third term. Okay, minus x squared plus y squared over root x squared plus y squared.
Okay, yeah. And then
That's still not working, is it? I've got a 2 I don't want.
Aren't we ending up with 1 at the end of this? Because we get 2 x squared plus
Be
y
0,
squared.
right?
I don't know. Like, aren't we just like I guess in the numerator just ending up with? Oh wait, I guess I need to see it out.
Yeah, it's not working. There's something wrong.
Yeah, I guess we're getting one over r basically.
Did I set up the field correctly? I mean, I think that's right. I divided by the square root of x squared plus y squared.
It's definitely the magnitude. Oh, and Power Star, I think you're talking about like a computer algebra system rather than AI with that. I agree. There's a lot of problems I'd rather just plug into Wolfram Alpha or something than solve by hand. But for this one, it feels really helpful to solve it by hand because I don't fully understand what's actually happening with this. But I agree. Like once you're good with something, just use Wolfram Alpha. Um, look back at what the book was saying.
Damn it, I don't see the mistake. Oh, wait. If I want it to fall away like 1 over r, am I supposed to divide by square root of x squared plus y squared? Or am I supposed to divide by x squared plus y squared? Oh, I think that's the mistake. Because, yeah, I'm making these unit vectors all the time, aren't I? Oh, that's the problem. Okay, I think I found out what's wrong with this. Let's try that. I think that's the mistake.
Okay.
Actually, that'll make this nicer. There's no square roots in it. What a mess this is.
It'll be a helpful mess though if we can figure this out.
Okay. Oh, sorry, I'm erasing what you wrote.
No, please do. It's not helpful.
I think I'm gonna, if it's okay, I'm gonna erase all this because
Yeah.
ugh. All right. Five minutes later, it's all erased. Okay. All right, so let's do this. So it's a quotient rule again. So x squared plus y squared times 1 minus x times, oh, this is going to be much nicer. Look, it's just, we can already see what's going to happen. Plus x squared plus y squared times 1, good grief, minus y times 2y over, all over the bottom squared. But you can already see it works. Because we
Yeah.
got x squared plus y squared here, x squared plus y squared here, and we're subtracting 2x squared and we're subtracting 2y squared.
Oh,
So
nice.
yeah, so it works. Okay, sorry about the long detour. We got that.
Huh. So if we had a, I guess the original vector we had was just minus y and x before we divided anything. That's increasing. Like it's doing the opposite. It's increasing linearly, and that kind of made the difference. We want it
Yeah,
to decrease linearly.
Yeah.
I wonder why. It's just the magnitude that we changed that affected the curl. How is that possible?
Yeah, I mean the directions are all the same, aren't they? But we were messing with just the magnitudes of this field at every point.
Yeah. So the intuition feels like the magnitude shouldn't affect the tendency to go in circles. But it seems to do that. I mean,
Yeah, we're
I'm getting more questions
gonna have
than
to
I'm
read
getting
that
answers.
Brad curl. Yeah,
Yeah, we need to read that book.
Curl.
Yeah. I'm kind of glad that we went here though, because like I feel like now I know something that I don't know. Like it gives me something to like think about more. All right, should we look at the answer for part B2 now?
Yeah, sure.
Okay. So coordinates, theta component. Okay, so we got the right answer for psi.
Okay.
Problem is that psi is multi-valued. Wait, were you right with that? Huh.
Well, that's what I was thinking, was that if I went from 0 to 2 pi, I'd be at the same place, but it would have different, yeah. Maybe that
They're
was the
saying that if you
problem.
just restricted it, it could be useful. I don't. What is this supposed to measure then? It's like, it can't be work as far as I can tell.
I don't know what it measures. What are the units of mu naught times I? Is that a Tesla?
Uh,
Or
well,
is it, I guess it would be a Tesla per times meter or something.
yeah.
Because if we've got mu naught I over 2 pi r for our B, that would be Tesla, wouldn't it? So I guess mu naught I would be Tesla's
Tesla
times
per
meters.
meter. Huh.
I think it's Tesla times meter, right? Mu naught I.
Yeah, I agree with that.
So if we got, so that's what we got for our potential function, Tesla's times meters. I don't know what that tells you.
I don't know
I
either.
don't know what that.
Okay, well, I'm gonna put a little slash to the little answer that I read out of the bottom there. It don't seem to be right, but Tesla meter. I guess that's telling you how I guess it's telling you um if we have multiple field lines, how much each of these, like the magnitude of each of these circles, like how much stronger they are as you get closer to the wire. I I'm still not sure how that is helpful for anything, but I guess a Coulomb meter could also, it's also measuring the strength of the electric field as you get closer to it. And imagine with a magnetic field, with each kind of like circle that you go in, it does get stronger in a similar way. You're not measuring work though. So I don't know what this is doing.
Oh, so you're saying if you're closer to the wire, you can go around a circle and it's like a shorter distance you have to travel to go around that 2 pi.
Uh,
Right.
it's just that like, I mean, it's really just like if it's mu naught I over 2 pi r and your r is smaller the closer you go to the wire, like the field is literally stronger. I guess these field lines don't do a good job of representing like field strength, but
Yeah, but what about our scalar potential? It doesn't have any r in it. It's mu naught I over 2 pi times theta.
for each, well,
I'm trying to imagine it like a lighthouse, it's like shooting out a ray of light and then you rotate that ray through 360 degrees. And as you rotate it around, it sort of covers all of the whole plane. It sweeps out the entirety of the plane.
it's still
So
increasing at a
every
constant
point on
strength.
the,
Oh, I guess. Oh.
yeah. Well, anyway, that one was
Yeah,
a mystery.
yeah. I the more I think about it, the more confused I get. Just bail out. Go to the next one. What's the next one? Okay. There's a vector potential question that I pulled here.
Okay.
Okay, number 18. A real potential, not like that other one. Okay, vector potential for a solenoid. A solenoid has radius r, current I, and n turns per unit length. Given the magnetic field as B equals mu naught n I inside and B equals 0 outside. I don't remember that. It's 0 outside a solenoid? Maybe I'm just misremembering.
Yeah, wasn't it kind of like a capacitor? You know how a capacitor had an electric field inside, but it was
Oh,
kind of 0 outside if you.
wait, but they're showing the magnetic field outside a solenoid in this figure.
Yeah, figure 618, right?
Yeah,
Well, I guess, yeah, it's just maybe they're saying it's very strong inside and very weak outside. I don't know.
I guess so.
maybe in the limit or as
They
you,
are a lot closer inside than outside, like the field lines.
yeah.
Or maybe they're just giving us a slightly simpler case to make the calculation simpler. Syntax, I didn't solve it generally. It was a lot easier if you use that initial condition. I could take a look at it after this though. Because there's a mistake somewhere in that integral that Zach did, but I couldn't quite find it for myself. Okay, I mean we can
ODEs?
just what?
ODEs.
Yeah, I don't earlier this week someone asked me a pretty neat OD that Tiratar found the solution for, but it was this one along some initial conditions. There's a pretty like neat trick to it where you multiply everything through by y prime.
Hmm.
Uh, Variable syntax error? Do you mean like constants? There should be two constants if you solve it generally. But it should be a function like y equals y of x. Yeah, so there'd just be two constants. And did you find the post that I made in Zach's Discord? Yeah, scroll up a little bit in the math chat. Okay, so did I not grab 6.41? Oh, I did. Oh, I have two more screenshots. Let's get these things in here. So that's 6.41 for us to refer to, and then I guess I grabbed the curl as well. That doesn't exist when I can satisfy initial conditions, huh? There must be a mistake then, because I could find one and I checked that it satisfied the original diffie-q. So what's the result of 6.41? This is all words, I was going to see an equation. The line integral of the vector potential A around a closed curve C. I don't know if that's supposed to be ds or what. I'm just going to say S though. That might not be right. What's the magnetic flux? S. This might be a little bit too more complicated than I thought. Hey, Anders. Um, Maybe it's well, okay. Maybe the line integral could be kind of simple because
Yeah, I'm just trying to think, where's our contour? Where's our closed curve for our line integral?
I I can't draw a solenoid. I don't think I know how, but like I'm imagining if like we can just follow like if I've just drawn the magnetic field lines, if we look at the exact center, we could draw a line through the center in that from that portion it's just mu naught and I times the length of the path. And then for everything outside the solenoid is 0. So we could draw like some kind of closed loop like that.
Okay.
Mu naught and I guess times the length of the solenoid. We radius r and turns per length.
Well, we could just call it length L if
I
you
guess
want.
so, yeah. then that portion is 0. Friend with Spain. Homebrew got the team a bottle of 70% alcohol. Oh, geez, be careful with that syntax.
I didn't even know you could get 70%.
I think Everclear's like 90 or something crazy.
My God, really? Sounds lethal.
I assume it tastes so bad that that forces you to not drink it too quick. And I think we get well, the magnetic flux. Oh wait, no, this is an A. The we're doing the line integral with A, and I just line an integral with B. The surface is the flux through a circle that we can draw. So instead, they're saying the part that we use the B for is the surface integral, so we could draw a circle like that just on one end of the solenoid and say that the flux through that thing is mu naught Ni times pi r squared. Oh, big R. I think. Now, how do we actually find A again? Oh, geez, syntax error. That's impressive right there. I feel like if we already know B, there should be an easy way to get A. Hey, Brian. Oh, it's like the potential function problem. The curl of A equals B.
Curl of A equals B.
So it's like that other one that we just did.
Yeah, that's what they want us to do in part B of this problem, isn't it?
Oh, really?
I think so.
Oh, yeah. Well, how are we supposed to do the line integral of A if we don't know what A is? Find the vector
Can we
potential
find current
A.
density? Hmm.
Could that just be I times some circle that we like we have to do some you'd like put some very small circles somewhere on the solenoid to measure the current going past it. And it'll be the area of that thing times I? Is that what J would be? But how do we get the area of that circle? Where's an easier way?
Oh boy.
I feel like the they're saying to find the vector potential A both inside and outside. So, oh wait, if we're just using the result, oh, the thing that I found, I think, like phi dA, that surface integral, we can just say it's equal to A times the length of the line. So like I guess if we're calling it L, like we just divide L to the other side, I guess, and we would check if that matches from the other thing that I just said. I think that's what they want us to do here.
Okay, well, maybe part B will be easier.
I that's what I think. Yes, I hope.
What about both inside and outside?
I assume there's zero
Is it?
potential outside. I don't see how you have a potential. I guess it'd be a constant potential, maybe. But, I mean, what's a constant vector? I don't know exactly how to address that part of it. I'm just gonna. I'll just go through the rote calculation here and see if we can interpret it after once we see everything.
Yeah.
B equals del.
So are we gonna make that? Are we gonna make that solenoid in the R theta? Yeah. So that the axis of the solenoid is Z, right? Is that what you're thinking?
Yeah.
Okay. Seems
That
to make more
works.
sense.
C hat and then del. Oh, I copied it in. Don't go to the appendix in the book.
Yeah, you got the cross product right there. Oops, why am I writing? Very sad scribble.
So, well, aren't these? Oh, I guess
So we want this to be non-zero, right? And everything else to be zero.
But isn't A theta and AR zero?
A theta may not be, because A theta has this extra R factor in it, right? You multiply an R into it before you do the partial derivative.
But then what would you say our A theta is?
Well, that's the question. Could we just make it mu naught Ni? No, that wouldn't work. One over R. How are we going to deal with this 1 over R out the front? Maybe we need, okay, maybe we need A theta to already have an R in it. Yeah, so if A theta has an R in it, then R A theta will have an R squared in it. And then the derivative will just have R and then divide by R and it'll cancel out. Maybe that'll work.
I guess the vector doesn't have a theta component. Uh,
Which vector are you talking about right now?
well, oh my, yeah, okay. I was trying to say, okay, we're trying to solve for a theta. Okay.
Yeah, yeah, we're
Uh,
going the other way. We're going the other way,
oh
yeah.
my gosh. Okay, thank you.
Yep.
So it's 1 over, so yeah, we'd say it's equal to 1 over r dr a theta d, oh, should be curly d, dr minus d d theta, like that. That's not,
Yeah.
okay. Okay.
I remember they did a problem like this in the chapter, and I was a little confused because it feels like you've got wiggle room. You're trying to take two partial derivatives. Oh, that's right. They made an argument that they kind of argued by symmetry that one of those components had to be zero, but I don't really remember why it had to be.
Um,
Because we could go with a theta, couldn't we? Or we could go with AR, or we could go with both. Maybe, we've also got those other two constraints. We've got to make sure the first two parentheses in the curl formula come out to zero. So,
oh yeah, yeah.
hmm. Here's a thought. What about, yeah, oh, you got an idea?
Oh no, I was just kind of like writing out what the next step would be. I don't really know what to do after this though. Like after here, we could look at the other parts of the equation. No, they should be 0 too. You're right. No, it's something we could just like look at though, honestly, and solve.
What if we tried a theta equals u naught NIR over 2? And AR zero, AR equals AZ equals 0. Would that work?
Um. Oh, that seems to work. So you multiply the other rn from the formula, and that cancels the 2 in the denominator. Would that break any other part of the formula? Like the other components, would they still be 0 here?
I think they are.
Yeah, because dA theta dz is 0. And then the theta hat component just says 0 and 0. Okay. Seems like it works to me.
Couldn't we also have like AR equals negative mu naught NI R squared theta or something? Does that work?
I assume this is going to mess up some other component. Maybe not, though.
Oh yeah, wait, but does it? Because the only other derivative with respect to AR is with respect to Z, and there's no Z here.
Um,
I feel like you could have either one of those two cases and then just let AZ be 0. I was confused with the similar question in the chapter. And I remember remember they made some argument that they just said, well, obviously this component has to be 0, and I didn't really understand why.
I gotta write that one out because I don't believe it at face value.
Yeah, it's probably wrong.
Because I think the theta is going away from the second one, but not from the first one. That seems like an issue. I don't think that gets us what we want.
The first one doesn't work?
I mean, it doesn't get us mu naught NIR. Like, it's the theta that's the problem, and the coefficient might need a little bit of adjusting too. But
yeah, let's scratch that one. Let's just take this. Let's go with the other one.
Okay. They were saying something like the potential function isn't unique unless you force the divergence to be 0. So I wonder if there are potentially more potential functions, and we're just like you can only take the one with 0 divergence. Oh, I don't feel like calculating the divergence of that, but well, how bad is that? Probably not that bad. Del dot A, because we only have the theta component. It's 1 over r dA theta d theta. So that would be 0 divergence because the partial of A theta with respect to theta is 0. There's a different issue where we expect this A theta to match the thing that I got from part A.
Yeah, I was just looking at that. You know, they have they're very similar. So if you let's see, can we somehow let the L be 2 pi r? No, no, because the L was the length of the solenoid, wasn't it? And
Yeah,
R was the radius of it.
it has like I think we need to figure out what this L actually is because this they didn't give us an L though.
But if that L was 2 pi r, which would be the circumference of one loop, right? Then those two things come out to be the same.
Circumference of one loop. Where's the loop in part B? Or is it maybe I'm not understanding what you're saying?
Well, I'm just saying, yeah, I wanted part A and part B answers to be the same. And I'm just trying to like, come up with a
Yeah.
band-aid to make them the same.
So we would want L equals like what? 2 pi r. Oh.
Yeah, if L was 2 pi r, I think they'd be the same. And also the lowercase r that we were using in part B would have to be that radius of the uppercase r.
So that would just mean you have a perfect circle going through the solenoid.
Yeah, kind of like one loop of the solenoid, right?
Yeah, but I guess it's like I'm wondering about the geometry of that. Cause like if I could draw a perfect circle, I'm imagining like aren't we going through the solenoid like that, but potentially? And how do you measure like the arc length of that upper piece of the circle that goes through it? Maybe it doesn't matter. Maybe I should just say that L equals 2 pi r, but I, what? Oh wait, no. if the line integral is equal to the surface integral, the line that we're integrating around is the border of that red circle that I drew.
So that would be one. We could make that one loop.
Uh, it would have to be in order for these, because you can't just do any surface integral is equal to any line integral. It has to be the line integral that like encloses the surface. So yeah, definitely the circumference of that circle is definitely 2 pi r. I'm confused on. I feel like I've situated this circle in the wrong spot though, because I put it just outside the solenoid where it should be 0. Maybe I should have put it inside the solenoid. But it's perpendicular. Sorry, what?
Yeah, I didn't understand for part A. I don't think I understood the C and the S, right? The curve C and the surface S. I wasn't quite sure where they were or where they were supposed to be.
I assume we're gonna like do one stage where it's inside and one stage where it's outside to get the two different pieces of it, but
Yeah. Yeah.
Should be just an R. Okay. So I assume so the issue is that if the magnetic field is along the z-axis like that, and the surface that we're drawing is perpendicular, wouldn't the line integral around the border of that surface be perpendicular and therefore be 0? Because the surface integral, like, I can definitely see that. The line integral I'm kind of confused on though.
Yeah, I like what you did for the surface integral because it was just the magnitude of the magnetic field times the area of that circle, right? Yeah. Wait,
So I must be misinterpreting. Maybe it is a loop like I drew initially. Do they not have to be the same surface?
well, couldn't if you thought of it from a sideways on, right? So let's say we had we should I can't draw a solenoid either, but let's say it was a bunch of rings. Let's say it was a bunch of rings like this, right?
Yeah.
Here's the solenoid. Okay, that's a solenoid. And now I'm thinking of the line integral. So the left-hand side of that equation. So couldn't we take some line integral like this, like up through the middle, and then it could be a rectangle, couldn't it? And come out and then come
Yeah.
down and back in like this. Yeah, maybe something like that, like down and that way and up through the middle.
Yeah. So like,
So does that give us what we?
I like the rectangle idea like a little more, but the issue is okay, what does 6.41 actually say? Equals a closed surface S bounded. The issue is that whatever curve you draw, so that rectangle you draw, it should be equal to the flux through the surface bounded by that curve. That's what 6.41 says.
Yeah, the magnetic flux through. Oh, so you're saying I'm not. Yeah,
The flux seems like it's
I think I'm
0
with you
here.
now. Yeah, my rectangle's bad, isn't it? So should it
I mean, it makes the
be?
line integral very easy, but this feels like it should be easier than it is. This means I think this is awesome. Well, if you don't know, I can see how it looks scary. Huh.
Yeah, because
Uh,
that rectangle I drew had zero magnetic flux through it, didn't it?
yeah,
And that's not what we want. Oh,
but like Stokes, like this is, I imagine this is basically Stokes' theorem, and that's a real thing. These do need to be related, or I guess it's the curl of f. Yeah, no, this is the curl though. It's like the Stokes' theorem isn't all like just like always equal to zero. So how does this?
well then
Oh
how about doing
wait,
what you said and just
it's because uh the line integral. Okay, we're doing the surface integral with the flux of the magnetic field. We're doing the line integral of the vector potential A though. We're integrating different things around the same surface.
yeah,
Okay.
yeah.
Oh, and we are our A is A sub theta. At least M per B, it varies with theta. So I could definitely I okay. um yeah, A sub theta is a constant. So I think if I borrow your solenoid picture,
Oh yeah, feel free. Oh, I think I see where you're going now. So multiply by 2 pi r, right? So kind of swing through the 2 pi radians or whatever.
exactly, yeah, and it's constant, so it's just uh like we would draw a loop
Yeah,
inside
that's
the
what I was thinking
solenoid.
too. Yeah,
Yeah.
one red circle right through the center of it. Yeah.
And that's A sub theta, not B. And so that should
Right.
agree, I think. um, and then if I switch to green and fill in the circle, that's when that loop that you drew. Sorry, no, that's just a surface. So we don't need a loop like that at all. Okay. And then for what about for the outside?
So let me make this
Oh
so let
yeah.
me make this a capital R, right? In part B, we should have had a capital R here.
Oh yeah, yeah. I guess you want to stipulate that this is only true inside the solenoid. Um,
Oh, so yeah.
and then A is just zeros outside. At least I assume A is going to be zero.
Sounds good to me.
It's simple. There might be some constant. I guess I could maybe see that. I don't know how he. I don't know. I'm calling it zero. I don't. I'm tired of thinking that hard. And so I guess we could do the same exercise, but draw the same loop outside the solenoid. Yeah, A should be zero outside. Otherwise, well, you probably make some argument on where the loop goes. I think it's fine. Just want to look at the answer.
If we drew a different curve, right, and we went outside the solenoid, well,
Mm-hmm.
wouldn't we still be we'd still be I'm just trying to think, would that still work? Because the
Um,
right hand side of this equation, we're still integrating over the inside surface, the
yeah, so,
flux of the B field, right? So wouldn't we get the same flux?
well, the B outside the solenoid is zero. Well, it
Yeah,
shouldn't be
okay,
even be
yeah.
an arrow, but. And so I think that means that if A isn't zero, it should be perpendicular, which seems weird, or A is just zero. But if A isn't 0, it should be perpendicular to this loop somehow. And I just don't
Thinking of it
imagine
like
it
this,
is.
like here's the solenoid. There's the solenoid. And now here's like the A loop out here. Or the, not the A loop, what
Oh,
am I, that's my curve, this is my C curve, right?
yeah.
My contour C. And so I'm thinking if I try and use this integral of CA ADS.
Oh, you're saying we can get flux through that?
Yeah, right. I mean,
I guess
because
so.
the right hand side here is what's going to worry me because I'm thinking of
Huh.
the right hand side as of composed of like the inside and outside of the solenoid.
Oh, yeah. What happens here? I wonder if we're crossing a discontinuity and we shouldn't, like, we should just place the
Yeah,
circle
so
entirely outside. That's what I was imagining with my drawing just up and to the left. But I think right as we transition from inside to outside, there's a discontinuity, and this equality probably doesn't hold for the exact reason that you're saying here.
oh, you're saying that the formula won't work if we go outside?
'Cause our Stokes theorem, it needs to be continuous for it to work, and the magnetic field, like, it's constant, and then it suddenly shuts off as soon as you get outside. So because it has that sudden jump, I think I don't imagine this would hold.
I think we could make it work though.
Oh, okay.
Maybe we have to, you know what? Maybe we have to also consider a curve inside that's not the whole radius of that circle, like maybe a smaller circle inside.
Um,
So I
I'm,
feel
I'm
like
sorry, what?
if you started right at the axis, right at the axis of the solenoid, maybe the vector potential A would be 0 right there. And then maybe it would increase as you sort of went out towards the actual loops of the solenoid and it hit a maximum value there because you got the whole flux through the whole loop, right? And then as you went out from there into the place where the magnetic field's 0, you would have to have A falling away and going towards 0 as you go to infinity. Something like that, maybe.
Mm, I think if we had a wire with current, we would expect that.
Oh, if we just had a wire.
I feel like that argument would work there, but
The picture I'm thinking of is something like this. You remember this graph from an earlier chapter? You had something that started at 0, went up linearly to some maximum. What happened to my pen? Oops. I did not mean to draw that 3 times. Linearly to some maximum and then falling away as you go
yeah,
out like this.
for like the field inside a
That's
sphere versus outside.
yeah, that's kind of what I'm thinking of. But I could be
Yeah.
barking up the wrong tree.
Well, I think for
That's what I
this,
was wondering if that was what A would do.
um, I don't think it's at least for like the B field for the actual solenoid here, it's like piecewise.
Yeah, so here's the radius of the solenoid right here.
Um, yeah, like right where it cuts off.
Yeah, right where it has that cusp.
Um, but I don't think we're going to
Scalidro
get
is
a
not playing
continuous
nice
A
anymore.
out of this thing.
Okay.
I have a hard time. I'm trying to figure out what A or trying to remember what A like measures. So there's like a physical explanation
Yeah.
too, but I don't really remember that. I just assume this thing is going to break as soon as we have that jump. Um, I know they do get the vector potential for a wire, but they don't graph it though, unfortunately. Hmm. Well, yeah, because I feel like what you would get from your situation would be like a non-zero flux and then zero for the line integral. And that seems like a bad thing. I'm gonna start looking for the answer.
Okay, we got Teslas times meters again for our units here for
Tesla's. Oh,
A.
that's a good
Does that
check.
seem,
Okay.
does that feel right? Tesla times
Um.
meter.
Oh well. Uh. N
Probably.
is per meter. R is meter. Yes, we're getting Tesla meters because the N and the R's units cancel. So that's good. Oh, I miswrote the answer for A. It should be over 2. There.
All right, well, I guess we answered it.
I This feels good, I think.
Yeah, let's see.
First note A must only have a theta hat component. It must point in the tangential. Oh, okay, that makes sense. Or well, does it make sense? I don't know how to tell intuitively that. I think we figured out at the end that A has that circle that's like parallel with the solenoid. I didn't know how to figure that out. Just looking at the problem immediately though. Each dA contribution points in the same direction as the J current that produces it. Okay. That makes sense. And you have to let the divergence of A be 0. So, okay, so A only has the theta component because it's parallel to J, and that goes in circles.
I feel like that's exactly what I was talking about before, and I don't really get it, but I'll take it on faith for now.
Okay.
Right? Because that's what we were talking about. We were saying, well, should this be theta or R, right?
Mm-hmm.
And it felt like it could go either way, but we did make the right choice.
Yeah, I
It felt
only
like theta was right.
yeah, the reason I felt better about the theta was that the R didn't seem to check out with the partials.
Yeah.
Not for this like physical reason. Um, Furthermore, A theta can have no dependence on theta or z by symmetry, sure. So the non-zero component A theta must be a function only of R. Okay. So then the actual answer for A, the magnetic flux is given by the line integral A dot dl. We take curve C to be circle with radius R inside the solenoid.
Oh my God, I was right. It's linear
Yeah.
inside and it falls away outside.
Ooh. Really? It does. All right,
Yeah,
I shouldn't have
it's
doubted
just
you.
like that graph. It's just like that graph from an earlier chapter.
Yeah. Oh, I kind of hate that. See the circle outside the solenoid.
Well, no, we kind of got, it kind of made sense that must have been what was going to happen because the B field only existed inside that circle. So once you went outside that circle, you'd hit your maximum, you'd hit the maximum when you got to the radius of the solenoid. And then as you went out further from that, you had that right-hand side of that equation we got from exercise 641, right? The surface flux of the B field was at that maximum. So the only way you could, I don't know, it sort of seemed to me that the only way you could get that maximum to stay was to have the A fall away as the circle got bigger. Because if you double the radius of the circle, you're doubling the circumference. So you got to sort of have the strength of A as you go around that curve.
I thought A would just have a sudden jump too, because it feels like for the B equations they gave us, the solenoid basically doesn't exist until you get inside of it. So like, why would the A ever change? But I guess that's just not right. And I guess like they do draw Gaussian surfaces. I remember in like chapter 2 across discontinuities of like the infinite plane. You draw it's half on one side of the plane, half on the other. All right. Well, I guess I was wrong. Not for the first time, but yeah, nice call there. What's for part B? Oh. Okay, so they actually integrated it. Oh, the math would have worked out. You could just integrate mu naught and IR with respect to R. Okay. And you get A theta is C over R outside. Dang it. Okay.
How did they do that part? Oh, because they just integrate zero and get a constant, like you said. See, that was
Yeah.
also what made me think of it. I was like, well, it could be when you said it could be constant outside, and there it is.
I guess I was relating it too
Except
much.
except it was constant over R.
Yeah. I was trying to relate it maybe too much to like potential difference for like the voltage. This vector potential is just a different thing. But it serves a similar purpose, I guess.
That solution is nice, isn't it? It kind of makes sense. I mean, it's just purely like following the integral,
Yeah.
integrating the zero to get a constant, and then dividing the R over to solve for A theta. Oh.
Oh, the answer has 2 more paragraphs in it. So wait, what was the last paragraph at the end? We see that any field portion whenever R yields 0 curl outside the solenoid. Innovation 12.303. Okay, for outside. It's a special case of this. All fields that proportional to 1 over R yield the same 0 curl. Really? I guess that's what we were talking about before with the field of...
Yeah, 1 over R. So maybe if it's tighter than 1 over R, like 1 over R squared, or if it's less, like the one I made didn't have 1 over R at all. It's just like this. In fact, it was scaling up with R.
And so, but 1 over R squared is fine because 1 over R diverges at the origin and Stokes' theorem comes into play.
Problem 226. I wonder if we did that one.
I bet I avoided it. We can take a look at it. Let me just read this last paragraph.
Yeah.
Some integration. It would yield an infinite b at r equals 0. So we must reject this. I feel like that's not... It's not convenient, so let's just throw it away. I'd rather say they force C to be 0 or something. Just rejecting it feels a little weird, but it's 2.26. It's only a 2-star. Consider the Laplacian of FR equals 1 over R. Oh, is it like the Gabriel's horn problem?
Maybe.
Or yeah, like one of our X is right at that border point where the surface area diverges but the volume converges, or I probably no, I think I have it right. I guess I could see something like that with like how a surface integral could converge, whereas a line integral, I guess. That's not really volume though. In this 2.26, they're talking about volume though.
I don't think we did that one. It doesn't look familiar.
I don't think so either. I don't know.
Oh, the problems in this book are so hard.
They are. They
Honestly,
feel really
honestly, I think this
instructive
is
though.
like, I think this is the hardest, sort of math or science book I've ever read, I think. Well, as far as the problems go, the chapters are okay. The text is pretty good.
Yeah, I think that's definitely true for me.
I work with students all the time who would like struggle with math, and they come in and I could see them struggling and I think, oh, this stuff's so easy. Now I know how they feel.
Yeah. Gotta keep you humble. Um, so there's only about 50 minutes until we get the 2 hour mark. So I have a bunch more like screenshotted, but I only see 2 of them as 1 stars. So I think maybe we just like keep it a little bit shorter.
Yeah.
You bring in.
Should we get a new?
One? I think this one will hold up.
Okay.
It hasn't yelled at us yet, at least. Okay, 31. One of the problems, or exercise, where everyone doesn't have the solution, but we have the solution key now.
Ooh, 1 star with a picture. I like it.
Yeah.
It gives me way more confidence when I see a picture.
Yeah, it does feel like we're just like guessing sometimes when we don't get a picture. 3 long straight parallel wires are located as shown in figure 6.40. One wire carries current 2I into the paper. Each of the others carry current I in the opposite direction. What is the strength of magnetic field at the point P1 and at the point P2? Well, P1 seems like it should be 0.
Yeah, I was just thinking it should be 0. But wait a second. Is it? Maybe let's not be too quick. Is the upper right and the lower left, aren't those two
Oh,
going to cancel out?
yeah, you're right, because they're on different sides of the point. Okay.
Yeah.
Uh,
No, am I right or wrong about that? Wait. Yeah, I think the upper right and lower left will cancel out at the middle at
I
P1.
think so too, yeah, because like one field, if it's going like that, the other one,
Yeah.
like they're going to be pointing into each other.
Yeah, right hand rule. That's what I was thinking of. Yep.
So I guess we're doing it like this. these ones like are coming like out the page towards us, and the other one there is going into the page away.
Yeah, did you learn those symbols as like the dot is like an arrowhead coming at you and the little triangles like the feathers of the arrow going away?
Oh, no. I kind of like that though.
That was how I learned it.
Huh.
You're either seeing the point of the arrow coming at you or you're seeing the feathers of the arrow as it goes away.
Okay, I like that. Hey, pen. Open or close points, solid dots surrounded by open dots. They're clopen points. So what's the
Oh, this is great. This is
hypotenuse?
this is great. I'm so glad we're doing this question. I know we can get this one. Oh
Yeah.
man, it's it's so good feeling confident, you know?
Mm-hmm.
That's why I've enjoyed that mechanics textbook. It's made me feel confident.
Oh, that one's yeah, you're just better at mechanics than I am, because that one's like shattering my confidence.
Oh,
uh why can't I do math in my head? It's 1/4 plus 1/4. Okay, so it's root 2 over 2d. There we go.
Penn Center High. You showed up for
Oh,
physics. It's very good.
yeah. We were just talking about like something related to like Stokes theorem up here. It was great, man. There's some awesome calculus. The F equals MA hasn't been as hard as the first chapter. I'm glad we stuck with it. Oh, good. Was the first chapter like kinematics? We
Yeah,
did.
good question. What was the first chapter? The first chapter had an example problem where you had a rope wrapped around a pole and there was a friction in the rope and you had to sort of integrate the friction as you around the angle of the pole. And it was really a hard
Oh,
problem.
okay. Because I was saying statics. Yeah. Okay. Yeah, those get pretty tricky. I guess we can define like say like the positive z to be coming out of the page towards us.
Okay.
Um, Wait, we don't even do we even need that? We're just talking about the magnetic field, aren't we? Um,
I always forget the formula for this magnetic field.
it's well, these are just
Mu naught
wires.
I over R. Is that what it is?
Mu naught I over 2 pi r. Some Pairs law.
IR.
What's the what do we call the direction?
You just work out the direction by a right-hand rule.
I guess so, yeah. So I guess we're saying like B sub P1. Um, so for the wire going away from us with 2I current, 2 pi root 2 over 2d. Excalibur doesn't always play nice with this tablet. I guess we don't care. I guess we only care about the yeah, they only ask about strength. And we already know that the other two are going to cancel.
Yeah.
So I guess it's just we can simplify this, but it's just the answer.
Yeah, I think so.
um 2 over root 2 is just root 2. I over pi d. Okay.
Nice.
So now at P2, What's happening? They're like
It'd be funny if it was 0 down there.
It's like from that one, it looks like that.
Yeah. Oh,
Yeah.
sorry.
Oh no, that's fine.
Every time
Then
I
that
come
one
back,
looks.
I got a thicker pen.
Yeah. So if they're not
And that's going that way.
interfering, I assume they're just adding.
Yeah,
Like
this is going to be 0, isn't it? I think this is going to be 0. And we've got a big one coming from up there. So how the heck do I do that? So it'd be like,
oh, is it gonna like
well, I would kind of like this anyway.
half of it is gonna
Going,
cancel with each one of the other ones?
I think so. But we'd have one going right and one going up. If this is P2, and then we'd have one coming down at 45 degrees. So I tell you what, let's factor out mu naught I over 2 pi, right? We're going to factor that out from each of these. So this one will be strength D because it was distance D from the point, and this one will be strength D. And this one will be strength. What's the distance there? DD.
Root 2D?
Just root 2D, right?
Yeah.
Yeah, and doesn't that, if I put those three vectors together, don't they just cancel? 1 root 2, yeah, it is. Yeah.
Oh yeah, because each component of this root 2D is just D.
Yeah, like I could move the D vectors. I could move the vectors here and here, right?
Yeah.
There, I've just moved those other two. Look at that. So yeah, it's gonna be 0 at P2. Beautiful.
B sub P2 equals 0. All right, let me I feel pretty confident in that, but we do have the answer key, so let me just see if I can grab it quick. Textbooks. Introductory.
Don, did you finish chapter 3 in that other textbook?
I haven't done every single problem. I think I'm feeling ready enough to move on though.
Yeah, I know I was talking a bunch of smack about it last weekend, but then I just played Tomb Raider all Sunday, so I'm still I just finished that chapter yesterday, I think.
Okay.
But I haven't read all the solutions.
Oh,
it takes a while just to read through the solutions too.
What? Sorry, my Firefox is being weird. Okay, there we go. Yeah, to read through the solutions of that mechanics book, each one of those takes a long time to get through. All right, we got part A, right? Yeah, we get 0 at P2. All right, nice. That's a nice little like a confidence builder.
I know. I like
the
questions
basic
like
ones.
that, you know?
Yeah.
I feel like that question, it's like, I don't know. I feel like there should be more questions like that. I think, yeah.
I can try to throw some more in.
Yeah. This textbook's been making me feel really dumb since chapter 2, I think. Actually, even chapter 1, honestly. By the time we were on the second meeting, I was scared. I was like, oh no, this book. It's over my head, but it's good. It's good to go over your head a little bit, I guess.
Yeah,
you know what? I don't
like
have any.
challenged.
I just don't have any. I don't have any mathematical courage. I really don't. I like doing things that I know I can do, and I'm like, as soon as I see something a little bit too out of my league, I'm like, I'm not going to read that. I'm not going to do that. It's too hard.
I for whatever reason with physics, I don't feel like that. Well, that's the math I do. but I don't know.
Yeah, you're looking at some. You said you're looking at some master's programs in physics or something, right?
Yeah, so I want to apply like two or three schools for applied math and then like one or two for physics.
Yeah, that's cool.
Um, yeah, the physics is kind
It's
of a
really
long
cool.
shot, but I don't know, it's just been so much fun to learn about.
Yeah, maybe I'll do that when I retire. I'll just go back to college and take a physics course.
That sounds kind of nice.
You know what I heard, and I don't know if this is true, but I heard in New York State. I live in New York State, and I heard
Mhm.
that the SUNY system. I work for a SUNY school, State
Oh yeah.
University of New York, SUNY, and I heard that after you reach a certain age, something like 65, I heard you can audit courses for free. So you can like,
Oh,
so I could go to the University of Buffalo and just, sit in the upper level math courses or something without paying for it. So sounds good to me.
you have to still be working at 65. That
Oh,
is
Penn
pretty
says you
cool
can
though.
do it in Canada as well. Cool.
Oh wow. I know there's some schools around me that do like open courses, but it's kind of like a limited thing. Like they'll do like it's not every course for sure.
Yeah.
She had someone in my linear algebra class too in Winnipeg. That was 65 plus. Wow.
Oh, that's cool. That's cool.
I like that. Wait, so
I get to take
is the 65 plus thing only for employees or is it for everyone?
I think that's for anyone. I mean, that's
Oh,
what
okay. So you
somebody
don't have to
told me.
stay
Somebody
working until
told me once
61.
you're like a senior citizen, you can just, take college courses and they don't charge you tuition.
Oh,
So
I love that.
I've already been taking a bunch of classes at my college with tuition waivers because I work there full time. So they
Hmm.
they sort of give you a tuition waiver to take classes. I
Yeah.
got something like a hundred and something credits over the last 10 years.
Oh, that's sweet. I'm trying to
But
think. When I was a tutor at a community college, I don't remember there being a program for that. But I was also like part time, so
yeah, I
probably for
don't
full
know
time
if
if there is.
I don't know if the college does it for part-time employees. I have a
Mm,
feeling you might have to be full-time to get
that makes
that
sense, I
benefit.
guess. Uh, I should just try to collect enough to get another degree. I mean, if it's free, Penn Center, and you got the time, why not?
Yeah, if you got the time, that's the thing. If you got the time and if you enjoy it, I just enjoy it. So why not?
Yeah.
The options there. But I kind
Oh.
of ran out of
Mm.
courses that were interesting because it's only a 2-year school. I'm at a kind of a
Mm.
small school. So I took some physics and chemistry and some engineering courses but I'm not going to take English or something. I don't
Yeah, I
want to do
wouldn't
that.
either. Thinking, I don't know. It might be college ones that I've seen. There are some cool ones like film class that I might would, would want to do.
Yeah.
I
Yeah,
don't
I
remember
took a
them all
couple
though.
Spanish courses and
Oh yeah, I'd like that too.
took a I took a course in nutrition and I took a web design course and I don't know, some electronics courses.
Oh yeah.
Yeah, I took a couple of Cisco courses like networking and routers and switches, that kind of stuff.
Oh, that's awesome. I've learned a little
Yeah.
bit about those, but not much.
Yeah, you'd think I
Hmm.
wouldn't you think I'd know something by now with all the classes I took, but not really.
I mean, I forgot most of my degree when I started streaming. The early parts of my stream are just relearning like Calc 1 and Calc 2. So I can see how if you don't use it, you're gonna lose it.
Yeah, well, you got enough people on YouTube keeping you sharp with that.
True. Depends if there's baking courses that you want to take. Oh, that's awesome. I'd love to do a baking course.
I haven't
Uh,
taken a baking course since like seventh grade high school.
I'd never have done one. My high school didn't actually. Maybe they had them. I never took it though.
They made us take home economics in 7th grade.
I didn't have to do any class like that until high school, even though it was like civics and economics. Those were the like most daily life class that I ever like took. The chef did macaroons, and their sourdough was always amazing. They sell us over the cafeteria. Oh, that's awesome. Oh. All right. Well, I guess I'll be another reading group.
Yes.
Um,
Pretty good day. Pretty good
yeah.
day.
So next week, I guess we can start on chapter 7.
I better get reading.
Yeah, it's really weird. I feel like I'm not following it, but we'll get through it, I'm sure. Because I felt similar, I guess, for most of these chapters. Yeah, the end is in sight. It's like we'll have like maybe 6 total more meetings, like 3 for chapter 7, 3 for chapter 9.
Oh, okay. All right.
So that's what I'm thinking. I'll probably write out in a Discord post later today or something.
Have you taken a look at that relativity book that Dr. Cook was talking about?
No.
No, I just looked at the, I mean, I skimmed through it just a little bit, and it looks, you know what? It looks readable. It looks readable. But I
Oh,
didn't look at
good.
any of the problems, so it could be just like this book. It could be.
Yeah,
Yeah.
I assume it's gonna start off pretty familiar at least. Reading was so fast. How do you do it? It seemed like all stream to solve one question. I think we're like I'm trying to keep it moving. Like there's a lot of these chapters I don't feel I fully understand still, but I think we've been picking up enough that we can get to the next topic. And I feel like I want more people to be involved in the group, so I don't want this one to go on forever. Like it'd be great if there's like a regular group of like 4-ish people or something. But this one is so far advanced that like I don't think anyone's gonna like try and jump into it and read 6 chapters to catch up.
Yeah, we really put a good dent in this book. It's crazy.
Yeah, I, I'm definitely very interested in reading the 3 chapters that we're not going to hit, but that would just be like a side quest.
Yeah.
I should check out the collab we're doing with Muhammad. Oh, I haven't heard of that. What is that?
All right, Don, I guess I'll hop out.
Oh yeah, sounds good. Thanks for coming by.
Yep. Thanks for everything once again.
Yeah.
See you in a week.
Later. Mm-hmm. All right. Awesome. These problems are so much fun. Let me get some music going. What playlist do I want to do? Chillwave / Dreamwave. Why not? That sounds nice. Then I'm gonna take a minute to switch over my Twitch and YouTube title and category. Answering math questions, chat, and studying. Category is math. No, category is math. Why do you never listen the first time I changed my category Twitch? It's like you don't pay attention to me. Let me change my YouTube. Oof. Where's my YouTube title? There it is. No, don't copy that part. Okay. And then, okay. And then I need the thumbnail, which is right. I'm sure you guys love this narration right now, by the way. This is great. Okay. YouTube's updated. Narration next. Thank you, Jed. Just announced a server collab. Muhammad is going to host all future reading groups I want to organize in hopes of getting some more folks into them and to allow people to organize their own. Oh. So like I seen Muhammad around in your chat, and I think he said hi in my chat a few days ago. Does he have like a server of his own, or like I'm curious, like I guess I'm not like familiar. Okay, I already downloaded this image so I can safely leave. We don't need this anymore. No worries, $10. We can try and like either start or end each one of our meetings with like a 1-star, and we can potentially do more 1-stars than that if they look nice. But it is nice to know that like we can at least do those basic ones. The hard stuff with like line integrals equaling surface integrals, who knows? But so I could go back to doing some mechanics, but I think I wanted to investigate in Zach's chat, I gave him an ODE and syntax error because there's a differential equation I did on Tuesday or Thursday that was pretty fun, and so since Zach looked like he had a minute, I wanted to see how he would do it. And then syntax error was asking what the general solution is supposed to look like, and I was thinking I might try and work it out because Zach nearly did it generally, but I think he made a mistake somewhere. And so the technique was we rewrote it as this. We multiply each side by y prime. No, bad. And then we integrate each side with respect to x. The integral on the left is y prime squared. The integral on the right, you can do a u sub with u equals y. Du is y prime dy. Sorry, 1/2 y squared. So the negative and negative are going to cancel. We get 2 over y squared plus c. 1. No. It's 1 over 2y squared. So you divide by the exponent. We're integrating with respect to x. Oh, why did I do that on the right? Technically, it's 2 times C1, but I don't care about that. I'm just going to write C1. Now, what I did here is I used the initial condition, and I think C1 turned into 0. Or maybe it didn't. But the problem just feels easier with the C1 kind of dealt with. But syntax error was asking for a general solution. So let's try and be general, I guess. This is a separable differential equation now. So we can say plus or minus y prime over, that's a terrible prime, root 1 over y squared plus c1 is equal to 1. Now we integrate each side with respect to x again. And this integral on the left was the issue. Y prime dx is the same thing as dy. And then I think what Zach did is get a common denominator on the left. So let's just do a little bit of side work. To work out this integral here. So if you get a common denominator, be 1 over root 1 plus c1 y squared. Oh, you know, Zach had a minus here, and that kind of broke things. I wonder if that's what went wrong. Because he has ended up with getting the square root of a negative number. Oops, why did I do that? I want to stay green. I'm... yeah, that's kind of funny. This y squared can get square rooted and go all the way up to the top. What's the point, though? And now a u sub is handy. 1 plus c1 y squared du is 2c1 y dy. So 1 over 2c1 integral 1 over root u du. Ah, Suna! Thank you so much for the raid. What were you up to today? I think this integral will get u over c1. Kill Bill? Yeah! I love Kill Bill. I think I've liked every Tarantino movie I've seen, to be honest. I love Tarantino. You melted your brain with computers? All right. Fair enough. I'll put the C2 over here, why not? Well, hope the brain melting was good. Tried a computer cluster but failed at the last. That does sound like something that's very easy to have go wrong. So Godspeed. Let's root you. Anytime networking is involved, things get very difficult, I imagine. Free melting part went really well. Okay, yeah, that was going swimmingly. Tarantino was pretty much rule. Yeah, I haven't seen Once Upon a Time in Hollywood. It's really bad. But like Pulp Fiction, Hateful Eight, uh, Jackie Brown. I'm forgetting a big one. Both the Kill Bills. There's one that I'm forgetting still. Doesn't he still have a big movie that I'm not thinking of? Hey, Kawaji. Having a strange debate. What is 100 divided by 4 times 2 plus 3? 5 or 125? Django! Yes! Reservoir Dogs 2. Django is just one of my favorite movies of all time. Thank you, Lubert. 2, take it or leave it. So yeah, Kawaji, I've seen many versions of like this type of debate, or like, you know, like they're all boiled down to the same thing, which is PEMDAS. Well, we can do the parentheses first. So you do 100 divided by 4 times 5. And now when you have, it's all division and multiplication. When you have that situation, you go left to right. So you do 100 divided by 4 is 25. Times 5 is 125. But those problems are intentionally made to just be stupid. So the third stream, including mine. Oh wait, was there? I talk about like was my other stream the first one? Yeah, I mean, I just wanted to resolve it because once I got to this stage here, I used the initial condition for y prime, and that made it a lot simpler. When you were doing it on your stream, and you were ended with like getting the square root of a negative number because of how that C1 was behaving weird. So I put my C1 in a slightly different spot, and the signs are, I think, going to work out better. Yeah, Kawaji, I hope that makes sense. Let me know if you have any questions about that. In the meantime, I'm going to go back to this. So, oh wait, one person said work left to right after brackets. The other said 4 times 2 plus 3 is together, so it should be 5. No. The other person is wrong. Like, what's inside the brackets goes first. So 2 plus 3 goes first, but the 4 is not inside the parentheses. So that's the important distinction. I guess the side work is done here. So we know the result of the integral. This plus or minus thing is where things get a little bit annoying, though. If you follow that, you end up with the numbers multiplication and division only. Yeah. No, I think that's a good explanation, Suna. Let's see what this is, Zach. The order of operations is wrong. Really? Get to the chase. It's not addition before subtraction. I was taught that M and D are interchangeable and A and S are interchangeable. I don't know what this person was saying before then. Yeah, sure, critical. I just want to look at this video a little more. Hey, Superion. Yeah, I'll put a link in YouTube chat. YouTube won't get the audio for this because YouTube is annoying with the copyright. The music going background with the music hears. Yeah, I'm live on YouTube too. I mean, is this point that we just always need parentheses? Eh. I mean, I don't know. I think the debates like that person says are kind of I mean, or the debates like the person in chat put are kind of like explaining the exact problem this person seems to be saying. Although I don't want to spend the entire time to like watch the video and really like think about it right now. It really doesn't matter which way we agree to do it, as long as you can always bring parentheses to get what we mean across. Okay, yeah. Spectry. It was a. Oh, you already said I forgot. You were here at the very start. Someone put. I'll copy paste the type of question. You've definitely seen a question like this before. It was basically like that type of question. And Zach linked to that video. The point is that the rules are including parentheses. Yeah. Like the person says, it's just like a convenient not to have to write them all the time, even though that introduces some ambiguity. Oh, okay. I can only sit in that position for so long with one leg up. Insuna, how did I get it so I can't hear on YouTube? It's because I have my stream audio split into different audio tracks. So in OBS, I don't use desktop capture at all. My audio set was pretty stupid though. I use a combination of OBS's application audio capture and a virtual audio cables to split my audio. And then I just don't send YouTube the music track or the browser audio track. But OBS's audio application capture is not perfect because of a Windows bug that is potentially fixed in Windows 11, but I don't know that for a fact. And virtual audio cables are also pretty freaking annoying. So it's possible to split your audio. If you want, I can definitely like talk more about it. Yeah. So I have different audio tracks for the Twitch live stream. Well, it's basically like track 1 is my mic. Track 2 is... What is track 2? I think track 2 is like video game audio. Track 3 is Discord. And track 4 is like music and Firefox. And so I have it so YouTube only hears my mic and any game audio if I were to play a game. Twitch Live hears everything. Twitch, the VOD for Twitch only hears the same as YouTube though. If you look like OBS like splitting audio, that's usually like you can find a bunch of videos about it too. It can introduce a lot of complications though, so just be ready to deal with headaches. And Terrabert, welcome in. So, no worries at all, Susan. I'm always happy to share anything about the stream, really. So yeah, my name's Don. The theme stream is I do math help, and so if I wasn't so busy just like yapping my mouth, I would do this question on screen from Critical Thinking that they're in chat. So yeah, I take math questions from chat, ideally homework questions. If you have a question for fun, then like depending if I can do it, I might still take a look if there's time. But yeah, I try to like help people out with their math homework. If there's downtime, I'll do some studying. So for the past couple months, I've been really enthusiastic about physics studying, but I've also done like calculus studying, analysis studying, all sorts of stuff. That's quantum mechanics math. Yeah. So that's kind of how the stream works. I also have days where I just stream games. As a warning, but my math days are Tuesday, Thursday, and Saturday. And you don't have to do anything you don't want to do, but whenever I see new faces, I like to let them know that there's a math niche on Twitch. It's not just me. So if you're interested in math but for whatever reason you don't like my stream, try anyone else in that list because they're all cool people. Hey, Brian. A stupidly complicated math question. Should I say it? Yeah, sure, you can say it. I'm going to start with this question from Critical, but yeah, you can always say your question, and the worst that I'll say is no. Do a Minesweeper? All right. I want to do this question first, and then we'll do the for fun stuff. Lagrange multipliers and a Rubik's Cube? Okay. Superior Knight, I don't know how to begin with this problem. I'm not sure what a Lagrange multiplier is. Yeah, it's a multivariable calculus thing. I haven't done Lagrange multipliers in a minute. I need to get Paul on the phone. Paul? Paul? There you are, Paul. How do Lagrange multipliers work? I need a Paul emote. I don't know what it would be, but where did Paul, where did you put Lagrange multipliers? Right here. Did you use that more? I see it recommended a lot. I really like it. Hashtag Paul's on my notes shill. You know it. Paul does math. Let's just go to an example problem. You always have these constraints, right? Lagrange multipliers. Oh, so we do have a constraint. So f is the function we're given, g is the constraint. How do you set this up, Paul? So yeah, f is a function we want to optimize, g is the constraint equal to a constant. And we want to solve for lambda? Or what are we doing here? So if lambda is minus a quarter, okay, you get those x's and y's. All right, let's start trying to do this math and seeing how it works out. So we're saying del f equals lambda del g. Yeah. So let's find lambda f, not lambda f, del f. So the partial of x is 2x. The partial of y is 2y. The partial of z is 2z. And then del g four x cubed 4y cubed 4z cubed. And now we say that del f is equal to lambda del g. I'm sorry, Critical, are you here? You might have tuned out because I wasn't working your problem immediately. Hey, Pen. Okay, good. I just want to make sure that thanks for your patience there. So plugging now, our del f is on the left. And then lambda del g looks like lambda 4x cubed, lambda 4y cubed, lambda 4z cubed. And then we can just split this out into a system of equations. So 2x equals 4 lambda x cubed, 2y equals 4 lambda y cubed. It's been a minute since I've done these, so I hope I'm doing this right. 4 lambda z cubed. I think so, though. Thank you for the follow, Terrabird. Looks good so far? Okay. Thank you for confirming. Is it? On mine, it still says 998. I wonder if someone unfollowed or if it's just being slow to update. It says 999 for you? Okay. Yeah, okay, it says 999. One more, man. How does one solve this for lambda when these are three separate equations? This feels... We can say that... Wait. Can we say that? X equals... Oh, okay, yes. Okay, yes. We solve each of these for the variable. So there is a slight issue where we have some factoring happening. Divide by 2, yeah. So like we would get 0 equals 2 lambda x cubed minus x. 2 lambda x squared minus 1. And all these other two are going to have the exact same form, right? So we can just switch the y's and the x's. Or the, yeah. 2 lambda y squared minus 1. 0 equals z 2 lambda z squared minus 1. And so what we want to do is figure out what lambda is in terms of... So I assume we're going to throw out the origin from all of these solutions. Like, we might need to check that separately. Yeah, actually, what is the question actually asking of us here? Two-string value problem is a solution with a maximum and a minimum value. Use Lagrange multiplier to find the extreme values of the function subject to a given constraint. Yeah. So maybe I don't know if it is definitely a solution, but like a potential solution that we should check. And if you can, or if you know already that is a solution, Pen, that's even better. It's been a long time since I've really like done these. I guess I can say f of 0, 0, 0 is 0. But what'll be probably more interesting is to look at the other case where 0 equals 2 lambda x squared minus 1. Once you remove it, you should be able to find, yeah. So we'd say 1/2 is equal to lambda x squared. And so we want to solve this for, I mean, x squared is good enough, I think. So that 1 over 2 lambda is equal to x squared. And by similar algebra, we can say 1 over 2 lambda is equal to y squared, and 1 over 2 lambda is equal to z squared. And now we can remember our original constraint that all of these things should equal 1 if you add them together. And we know what x squared, y squared, and z squared are. So if we have x squared and we want x to the fourth, let's just square each side. 1 over 4 lambda squared equals x to the fourth. Same thing over here. And we know that if we x squared, x to the fourth plus y to the fourth plus z to the fourth is 1. And we know what all of these variables are in terms of lambda. 4 lambda squared, 1 over 4 lambda squared equals 1. So this is 3 over 4 lambda squared equals 1. We can say 1 over lambda squared equals 4/3. Flip each side is 3/4. Take the square root, plus or minus root 3 over 2. 0, 0, 0 may not satisfy the constraint. True. Yes. Because 0 plus 0 plus 0 is not 1. Okay, good call there, Pen. Thank you. Actually, no, but 0 to the fourth plus 0 to the fourth plus 0 to the fourth is not equal to 1. Okay. And so if lambda does equal plus or minus root 3 over 2, we should be able to figure out what x, y, and z are. So if we let lambda be the positive root 3 over 2, we should get x, looking at this equation here, x squared equals 1 over 2 times root 3 over 2, which is 1 over root 3. We're going to take the square root of that, which is annoying. So x is equal to plus or minus 3 to the minus a fourth? Because 1 over root 3 is equal to 3 to the minus a half. That solves this equation you're looking at, not just the original constraint. Okay. This is case 2 or still case 1? I guess this is, I'm looking at case 1 where if the cases are like, we have 2 values of lambda here, plus or minus root 3 over 2, I am still in case 1 of positive root 3 over 2. We need to check case 2 with the negative. And y and z have the exact same forms, so I think y can also be plus or minus 3 to the minus a fourth, and z can also be plus or minus 3 to the minus a fourth. If lambda is minus root 3 over 2, so case 2, x squared. This one we shouldn't get an answer for. 2 times minus root 3 over 2 is negative 1 over root 3. But x squared can't equal a negative number because we're not dealing with imaginary numbers. So we don't get any solutions. When lambda is minus root 3 over 2, and that's okay. You don't have to get a solution from these. So there's a bit of an oh, you know what? Okay, so I was just wondering if x, y, and z could all be plus or minus 1 over the 4th root of 3, like you could equivalently write these as like 1 over the 4th root of 3. Like in theory, we need to check 6 different cases or maybe even more for like, what if the first one is positive and the next 2 are negative? Or what if just y is positive and the other 2 are negative? That's more than 6 cases, isn't it? I don't know. Either, but it doesn't actually, the signs don't actually matter here because the original function squares everything anyway. So we don't have to check all these cases. We can just kind of tell they're going to all be the same number. So it's good enough to just look at f of 3 to the minus a fourth, 3 to the minus a fourth, and 3 to the minus a fourth. It's symmetrical, so theoretically we should have symmetry in our answer. Yeah. So it's x squared plus y squared plus z squared. So we're squaring each of these inputs and adding them. Okay. So it's 3 to the minus a quarter plus 3, or a half, plus 3 to the minus a half plus 3 to the minus a half. Which is 3 over root 3, which is just root 3. And so that's our extreme value of the function. And so I think that's just the answer. They're not asking if it's a maximum or a minimum. Like, if by cases you're talking about, well, we have to determine if it is a minimum or a maximum. But like, if by case 2 you mean for the lambda values, then that's case 2 right there. No, we didn't get anything from case 2. The only solution we got was from case 1 with the positive root. And so we got actual x, y, and z values for that. And so I took the case 1 solutions and I plugged them into the original function to get what the actual value is. Superion, oh, I'm sorry, I missed that. But yeah, it basically is that. Don't ask me why, but Dr. L, how do you use the Gaussian addition formula to add the numbers from 9 to 14? Well, it's got to be 669. But just because I can't resist a good meme. Isn't it? It's 1/2 nn plus 1. 1/2 14 times 15 minus 1/2 times 8 times 9. 7 times 15 minus 4 times 9. 7 times 15. 75? No. No. I don't know why I said no twice. Why can't I? It's a maximum at root 3? I saw Dr. I'll put that in Zach's chat too, but it went by the wayside, and I can't let a 69 go by the wayside. Oh, and wouldn't you know it? 69. There you go. Maximum occurs at root 3. Yeah, let's just see the graph of this. I assume we just... How is it possible for there to like not be a minimum? Like, what does that graph look like? Yeah. I'm just wondering how we know it's a maximum, I guess. Just like, I don't know how to see it just from the math there. We probably need to do like some gradient thing to actually know that, right? There is a minimum? Then we missed it. Or I missed it. Oh. The minimum happens when we let x equals 0 and y and z be free? Well, y to the fourth plus z to the fourth still have to be 1. What is that graph, by the way? Y to the fourth plus z to the fourth equals 1? It's not important right now, but... Like, why didn't we get that? Paul? I'm holding you accountable for this, Paul. No, I mean, that should have been it, but we're missing something. You're trying to use ChatGPT to figure it out? Cytos, front lies of n make the function that thing positive for all real x. Oh god. I can take a look at them in a little bit. There's a couple of things that like piled up. Because Terabert also put a question earlier that I haven't gotten to yet. Critical, you're saying find f prime, g prime, z prime. Gradient is f lambda, gradient g. The first step is to find the gradients, not f. Like f prime doesn't have a good meaning in multivariable calculus. Yeah, so not. Yeah, and so that prime is a gradient, just to be clear. But I know you can't really do the triangle with your keyboard. But as long as you understand that the prime that you're typing, okay, yeah. So yeah, you find the gradients. You set the gradient of f equal to lambda times the gradient of g. Solve the resulting system for x, y, and z in terms of lambda, and plug all those things you get with lambda into your original constraint equation. And then that lets you get lambda. And then once you know what lambda is, go back to your solutions to the system of equations and plug them in. And once you know what your x, y, and z are, oh, skeleton, you might be my 1000th. You're my 1000th. Thank you for the follow, skeleton. You have the honor of being my 1000th follower. But setting x equals y equals 0 and z equals 1. Awesome. Okay. Well, I'm officially going to do a giveaway in the Discord. I've been giving a bunch of keys to random games. Wait, you're not Boodib? That feels like a thing that Boodib would say. Dude, if you're my 1000th, not Boodib. It's been a minute. I hope you've been well if you are not Boodib. Not. I don't know. 1,000 viewers? That'll be the day. How do I know if I need to find the XYZ values first? Well, you use the lambda that you find to get XYZ. Integration by guessing. Thanks for the follow as well. 69K viewers? Yeah, exactly. Yeah, that is a great name. That's truly the best way to integrate. If you can just purposely guess it and just take the derivative to prove it. It's like a squared, squished / rounded cube. Interesting. That's the constraint. The function that we're optimizing is the f function, which I don't know what that looks like. That's a that's a 4-dimensional function, so I definitely don't know what that looks like. So yeah, everyone, keep it on the Discord. I have a bot picked out to do the giveaway with, but I'm gonna have to figure out how exactly to set it up. But sometime after the stream, and I'll probably do an @everyone ping. I thought I was on the journal page. If x equals 0. Oh, yeah. Okay, so back when we were up here, we don't have to let them all be 0 at the same time. Yeah. Okay. Okay, so critical. If you did have a question on something I did before, please do ask it again, because I'm not sure if I lost you at a certain part. But the mistake, it's like we've gotten part of the right answer, but we've missed something. Because at this stage here, once we had these equations, I immediately threw out anything involving x equals 0, y equals 0, or z equals 0. And that was wrong. We need to consider what happens if each of them equals 0. Okay, so yeah. Annoyingly, we have a lot of things to check now. Well, no, they should be symmetric. So in the world where x equals 0, we know from the constraint, or the constraint becomes y to the 4th plus z to the 4th equals 1. And we still know that y to the 4th is 1 over 4 lambda squared. And same with z. So we can plug these things back in. Was it really 1/4? Where's I getting 3 from? Oh, 3 was from the... Okay, yeah. Okay. I get it. I'm just being crazy. Equals 1. So that's 1/2 lambda squared equals 1. 1 over 2. Oh. Thank you so much for the prime. Not booted. If you made that account just to follow me, even bigger thank you. I really appreciate it. Solving this for lambda plus or minus root 2 over 2, that becomes... You're very discreet. God damn it. I miss your jokes, Booted. You do what's best for you, of course, but I'm glad to see you. Some continuous viewer would say. So if lambda does equal plus root 2 over 2, x always equals 0 because we're in the magical x equals 0 land. But y would equal 4 times 1/2 because it's lambda squared. Should equal to 1 over 2. And we get the same exact math for z. Okay. And then for lambda equals minus root 2 over 2, for the same reason, we're not going to get any solutions, right? Oh, shoot. No. Oh, my God. It's to the 4th. It was y to the 4th equals that. And we write this 2 to the negative 1. So 2 to the minus 1/4. Ew. Plus or minus. So z is also plus or minus 2 to the minus 1/4 because it's going to be the exact same math. It is a tricky problem, Superion, yeah. Oh, wait. Why is it lambda? Wait. I started to use this equation, whereas I used that equation before. And they are slightly different. I should use the top equation. Okay. I haven't done enough erasing and redoing the problem. Let me erase this and redo it one more time. Ugh. With the Lagrange multiplier, it's not necessary to solve for lambda. If y to the 4th and z to the 4th are both equal to the same function of lambda, the only function you need is y to the 4th equals z to the 4th. So y equals z up to sine. And we know they have to add to 1, which is how you work out it's... Well... You're probably right, or you're probably right, Luber, but... I guess I'm trying to maybe do it a procedural way? Or I don't know, this is probably also procedural, but I'm not too good with these, so I'm... just gonna do it the slow way, I guess. There probably is like a fast way like that you say. Okay, so sorry, I should have used these equations I was using before. So y squared is 1 over 2 lambda times root 2 over 2, which is equal to 1 over root 2. And I'm going to rewrite that as 2 to the minus 1/2. So then y is plus or minus 2 to the minus 1/4. So it's only a bit of work, so it never hurts. Okay, cool. And z is going to be the same thing. Okay, and then when we have lambda equals minus root 2 over 2, no solutions. Because we're going to end up with negative square root. Okay, and so that means f of 0 for some reason we can choose, like, the plus and minuses don't really matter, so I'm just going to choose the pluses because everything's being squared anyway. So 0 squared plus 2 to the minus a half plus 2 to the minus a half is equal to 2 over root 2, which is equal to root 2. Okay. So now we have two extreme values of f because we don't really need to check for y equals 0 or z equals 0 because we're just going to end up with the same root 2 value. Holy shit! Anonymous! Thank you so much for the 10 gifted. Holy crap. I hope everyone who got them enjoys it. Thank you so much for that. It's been I feel like I've really been grinding to get 1,000 followers. It feels nice to finally get there. Thank you so much, Anonymous. Superion, technically yes, but we're gonna get the exact same thing back out. There's no, like, just by looking at it, we can see it's gonna be like x equals y equals z from like all of these equations are the exact same for x, y, and z. We're not going to get a substantial difference from letting the other ones equal 0. Oh wait, oh, you're saying if, oh shoot, no, you're right. I misinterpreted. If 2 of them equal 0. Oh, okay, that is a different case. Okay, God, okay, this is a lot more complicated than I thought. Dude, I feel like I should have something more to say about hitting 1,000 followers, but it's just, thanks so much everyone who's been with me for it. This is I didn't think I'd enjoy streaming as much as I do. I'm kind of a big introvert. But I just kind of like started trying it, and just like the amazing people who come around to these math streams are also just the stream in general. Just really like I don't know, keep me motivated. L union L or something? Oh, you want to type lol? Okay. You can type whatever you want. Superior, that's a great catch. If x equals 0, y equals 0 is definitely a different case here. Doesn't that mean lambda equals 0 though? Or wait, no, that means from the constraint equation. Alright, so we don't have to go to lambdas here, because we know x to the 4th plus y to the 4th plus z to the 4th has to equal 1. And this is a trick that Lubert is saying, I think. we know that z to the fourth should just equal 1. Obi, thank you so much. Welcome in, everyone. I hope your stream was good. Z is equal to plus or minus 1. Streaming on a Saturday. Is that usual for you? I don't think it is. It was a good one, though. First a little Lagrange multiplier problem. Not typical. Okay, yeah. And I think we've nearly gotten to the end of it. There turned out to be a bunch of cases for us to check here. Yeah. We also just hit maybe 10 or 15 minutes before you rated 1,000 followers. Open problem last night from last night's Satisfactory stream, so we wanted to finish it. Oh, okay, nice. So yeah, I don't know. I've been kind of at a loss for words for like what to say, but I don't know. I'm just gonna keep on stammering if you guys don't mind. Serve it. Thank you. And I'm sure it'll happen for the rest of the math streamers soon enough too. Besides Gold, who's already like well past it. A hype chest. Personal best emote. What? Oh, okay. Who cares? Okay. So critical. I'm sorry this explanation for your problem is so fragmented here. Okay. Trying to summarize it though. The first steps we've gone over. We find del f and del g. We set del f equal to lambda del g. That's Lagrange multiplier. We get something that looks like that, and then we can set up a system of equations by setting the x component equal to the x component, and same with the y's and z's. And when we end up with like an equation like this, we want to isolate x in terms of lambda, so get x equals something involving lambda. But the trick is all these three equations look the exact same. So once we know what x is, like y should just look the exact same thing, both y and same with z. And so potential values for x, y, and z are either 0 or like plus or minus the square root of 1 over 2 lambda. Like, oh god, something like that. And so the thing that tripped us up here is that we have a bunch of different, we need to check basically every combination of 0. Like x, y, and z can all individually be 0, positive root 1 over 2 lambda, or negative root 1 over 2 lambda. And so thankfully, you don't have like the 27 cases, or however much that would actually be, because we can take advantage of the symmetry of the original function that we're given. It's just x squared plus y squared plus z squared. So the squaring means we don't have to care about negatives, because we're always checking the positive version anyway, and a negative squares to a positive. And then if you let x be 0 and check what y and z must be, you'll always, and then you go and check, and then if you let y equal 0 know what x and z must be, well, it's going to be basically the same thing because the equation just looks the same. So we only really have to check when all three of x, y, z are equal to the thing with lambda. And there's two other cases to check when just one of the variables is 0. And then the last case is when two of the variables equal 0. It doesn't matter which ones you choose. It's actually a nice trick since f of x is homogeneous to degree 2. We've got g equals 1. G is homogeneous to degree 4. Homogeneous function x df dx plus y df dy plus z df dz equals kf, where k is the homogeneous degree. Get a simplified equation. Huh. Because in the words of variables, you don't know which one you need to plug in to find lambda. And so I haven't actually answered the actual question yet. We have found the ooh. Did we throw away? Okay, I have to figure out a little part here, but let me address your question first. Critical. I get confused when there is more than two variables because I don't know which one I need to plug in to find lambda. When you have to use gradient x equals lambda gradient y. I think generally it's whichever one looks easier. For this one, the f and g functions, I would call them like nice, where you don't kind of everything ends up being the same. Do I need to do x, y, y, z, or x, y, y, z, z, x, or all of them? I don't think I understand what you're asking. Which one do you need to plug in to find lambda? So you want to find what each of the variables is in terms of lambda, so you need to do that for all of them. Oh, okay. Maybe I get what you're saying. Yeah, you need to do it for all three of the combinations. So, like, you always need to take the first one equals the first one. The second equals the second. Third equals third. Yeah. And so you always want to isolate the variable. Yeah, sure, Anders. Sorry, this question ended up taking a while. There you go, refunded. You're gonna always need to equate those. Um, but okay, there is a different part of the question where we found three. So like one extreme, or at least like we've gotten three results. Like we've gotten one for an extreme value. We've gotten root 2. And so the answer to the question critical is the actual value of the function. Like that's the extreme value. And we have three options here, which are root 3, root 2, and 1. And so I think we would say the maximum is the highest one of our options, which is root 3. And the minimum is is just 1, which is the smallest of the three. The root 2, I guess we throw it out. Maybe it's a local extreme or something like that. I don't know how to interpret that root 2. And I wanted to graph this, but it's 4-dimensional. So that's a little bit difficult, isn't it? But I think the final answer to this question is that, what's that? Critical. And there's only one extreme value. How do I know if it's going to be max or min? That's a good question. Depending on the problem, you could just plug in values. Potentially, yeah, as long as they also fit the constraint that you're plugging in. Um, you know, two simplex, but they get to change the starting location. My DMs work against students on purpose at different diagonal slices of the 3 simplex. Trying to code in some things. Oh, I'm not even that good at coding, so that doesn't bode well, will be. Critical, you ask a very good question. I assume you can tell with like with a gradient. It just you need to be particular about what direction you're looking at, which that's the part I don't know how to answer. Check the constraint function in Desmos and check it out. The function f is essentially the distance to the origin. Oh, neat, Lubird. Yeah, that's true. I guess the square of the distance, but that's okay. I just want to see if I can get an answer to Critical's question. Does the Hessian even help, though? When it's subject to a constraint, like, couldn't it get you the wrong answer if it's looking at things that are outside the constraint? That's what I don't like about this. A second derivative test for constrained extrema. Maybe I should actually read the post. Suppose A is a constrained critical point of f on the constraint g of x equals c, then we have del f of a lambda del g of a for some scalar lambda. Consider the Hessian matrix A of f of x minus lambda g of x evaluated at a. What are these V's? Or news? I guess a vector? Oh, for inputs, I guess? I don't get what that... I don't understand the sentence. Yeah, I guess this is how you do it. You can do a similar thing to the I feel like a simpler thing is to get any other point that fits the constraints. And plug it in. It does seem like there's a rigorous way of doing it, but like I would just let, like, you know, both x and y equal something relatively simple like 1/2 and figure out what z has to be. And then you would have the, like, if we were to do it for this one, I'm just gonna, like, you know, just pretend x equals 1/2, y equals 1/2, and then figure out what z must be in order to fit the constraint. So we get 1/4 plus 1/4 plus z squared equals 1. So z squared equals 1/2. Z, I'm only going to use, I mean, okay, we can do plus or minus root 2 over 2. And so we could just plug in the point 1/2 root 2 over 2 and see what that value is and compare it. You know, if it's less than, then you found a maximum. If this is more than, then you found a minimum. That's probably the easiest thing that you can do. Rather than trying to figure out... Wait, what? How come I didn't get that? Did I get that? God fucking damn it. How do I also get 1 here? Oh, it's z to the 4th. I did the wrong point. Okay. Z to the 4th equals, I'm gonna just say 2 to the negative 1. Z to the 4th equals, plus or minus 2 to the minus a 4th. That's what it should be. So I'm just gonna randomly choose the positive one. So 2 to the minus a fourth squared is 2 to the minus a half. There you go. So 1 half plus 1 over root 2. That is 1 plus root 2 over 2. Which is a little bit more than 1. And so if, say, you only had, like, if you only found 1 as the result of your thing, you would say that this 1 must be a minimum because you found a value that's more than 1. Yeah, Zach, we finally hit it. That's probably the simplest way rather than trying to do that second derivative thing. Yeah, no worries. Jeez, okay, I thought it would be a quicker problem. With Lurkin, I appreciate it. Thank you, thank you. Okay, I don't know if they're still here. I wouldn't blame them if they weren't. But Terabert, a long while ago, you asked a question. You said it was an intentionally like difficult question. An easy question asked too complicated. Assuming Max hypothetical spurious object, we say that he moves forward using kinetic force at exactly 5 kilometers per hour. Well, that's not a force. How long does it take to travel the physical distance of 300 kilometers? If all things look like friction, acceleration, and so on are neglected. 60 hours? His question. Okay, yeah, that is asked too complicated, I guess. Okay. I was a little bit more afraid when I first like looked at it, but I think that's okay. Okay, so Zach did redeem a Minesweeper 1 hour ago now. So let's go and do that. Minesweeper. Isn't this the big one? Let's do intermediate. Max to be hypothetical spurious object though. No worries, critical. Sorry, my explanation to that was kind of crappy, but I was kind of feeling my way through the question. Dude, this is just RNG up here. It's RNG Island. I'm gonna send that one. Damn. Okay. It's okay. Oh, I fell asleep right there. A yerba mate rush? You're still on that? That has to be a hell of a rush. Has so much caffeine. Like an amount of caffeine that just like is not okay to me at least. We got more RNG here. Gotta love the RNG, yeah. Also, Minesweeper is cool. Yeah. Yeah, on Twitch I have a redeem so people can make me do a Minesweeper Superion. So that's what this is. Okay, we got RNG with these 4 things here. Let's send that one. Hey, okay, the RNG was what was on my side there. If I don't like, if I just know by looking at it where the mines are, then why would I flag it? Now I do misclick all the time, but yeah. Oh, you know, I wanted to look at the graph of the constraint. Where's 3D? This must change how their website looks, and I don't like it. I don't like change. Oh, here we are. Do you mean by that? Oh, that's true. Skeleton. We definitely just met. I have no clue who you are. So do you like yerba mate? Oh, I kind of like this is a pleasing cube right here. I like this cube. I would eat a candy in the shape of this cube. There's already a candy shape of this cube, isn't there? Oh, dude, there's like a little like mint candy that looks like this. I swear. It's like a rounded cube. So, oh, that makes sense why 1 was the minimum, because the minimum happens like right on the like X, Y, and Z like axes. You do like your mate. Okay, that's good to know. I'll remember that, skeleton. It's like I couldn't decide if it wants to be a sphere or be a square, so it decided to be both. Squircle? Yeah, true. How can we combine sphere and cube? Cube? No. Sit. Cure? No. I don't know. Spube? That sounds gross. It sounds like pube. According to topology, it's technically the same? Probably. I don't know how topology works. They'll probably call this the Eiffel Tower. It's a new STD. Quare? Oh, yeah, no, if you pronounce that the way it's supposed to be, yeah. If you pronounce it so it rhymes with sphere, it does sound bad. Okay, get this Lagrange multiplier off my screen. What? Where am I? Oh, I scrolled up to the top of the page. Okay. Should we go back to this differential equation we were working on like an hour ago? I think they'll call it the Eiffel Tower, then I agree. You don't know how topology works. Just let me live in my fantasy that they call that the Eiffel Tower. I'm much happier living in the world where I don't know how topology works, to be honest. um Actually, is this just the solution right here? Oh wait, no, actually this is still wrong. This The right answer is y equals root 6 minus 2x. And that, like, it's y squared and there's a square root. So something's amiss. They are locked. I did. I'm sorry that I pay attention to my chat. Worst streamer ever, I know. Superior, the problem came from this differential equation at the top here. And so I solved it with the initial conditions on Tuesday or Thursday. Well, more like Teratar solved it for me. But there's I didn't solve it in general with C1 and C2 still here, and that's a lot more challenging. Reading chat, yeah. I mean, yeah, hard. Like I remember you were pretty infamous for not like reading your chat. Right? It's like, taken for forever. How dare you be immersed in the game? It's terrible. The only thing that matters is chat. Took topology with algebra for the first week or so. It kind of makes it polymorphisms and homomorphisms. I actually make that mistake. No kappa needed. All the morphisms are gonna feel the same. I mean, still, when I think about like less than or greater than, I either have to imagine the alligator mouth eating the bigger one, or I have to remember that more people are right-handed, and so greater than points to the right. I need those stupid tricks, or else I'm gonna misremember stuff like that. Chat worthy, time to throw and go on a trip to bronze. It's not my fault I'm bronze. I'm just too interactive of a streamer. Okay, I'm gonna put I can't figure out this differential equation like for this like for like that stuff there. I just do not know why this is wrong, but it seems to be wrong. I think I'm just gonna put the equation down for now. I don't know what I want to do instead though. I'm kind of done with these chapter 3 questions. I've done so many of them. I still have more that I could do. Geometry notation, some geometry notation scares me a bit. Too many indices can be confusing. Oh yeah. And like there's some types of math where you get like 2 or 3 levels of subscripts. .16 was a good one. Oh yeah, that's the last one that I did. It was a pretty neat one. How's the E&M? It was good, Cook. We were really a lot of it had to do with basically being confused about applications of Stokes' theorem, I think. Let's see. Like, which one was it? Uh, yes, like 18. Why is this a hand? Can I stop being a hand? No, don't do that either. Why? How do I? No. We're working on number 18. That's what I'm thinking of in particular. Uh, and the result from exercise 6.41 is that the line integral of the vector potential around A, around a closed curve C, equals the magnetic flux B through the surface S bounded by the curve. Good E&M book for math-oriented people. Oh, yeah, that sounds interesting. Skeleton, not booted. So yeah, we did that one involving like the A vector potential. Well, we tried it. I think we kind of got the idea. Fembox nailed it, and I was a hater though. Then we also did number 15 about this hypothetical thing you could define to be a scalar potential for magnetism. Which actually, again, Fembox nailed, and I did not. So more on the phone the other day. He's currently preparing to teach a math methods course for sophomore physics majors. Ooh, cool. I pushed you in the right direction on that one. Honestly, I don't remember how discussion on this one went. But yeah. Anyway. Next week is going to be for we're going to start on inductance or induction. Yeah, weird if like going like back and forth. Um, I'm kind of debating. Like, I feel like I should do mechanics, but I also don't want to do mechanics right now. I kind of want to pull another E&M question. That's how I'm feeling. A little down? Oh, dang. Because grad psi, the loop integral will always have to vanish. It's not allowed for Ampere's law. All right, see you, Superion. Thank you for the help there. Um, oh, yeah, if it's... Okay. Applying for jobs, yeah. It's kind of the worst. Um... Ooh. Okay, 6.17 could be interesting. I want to see, what was the answer again for the sphere, though? I want to see how they did 11 again, and then maybe we can try it with the cylinder. Yeah, never having to work, I think, is the ideal thing. So they use Biot-Savart. Biot-Savart. Oh wait, but our cylinder is solid, and this sphere is a shell. So it's not going to be that applicable, right? It's probably still Biot-Savart, Biot-Savart. But we're gonna have to use it. I don't know, man. Let's just get into journal plus plus. It's the first step to solving the problem. Hey, bad. Okay. Electricity magnetism for mathematicians, a guided path from Maxwell's equations to Yang-Mills. Ooh. I'm doing well, Cook. Thanks for the recommendation. Skeleton. Feeling kind of old lately. It's trying to catch me where the age-reversing nanobots already. Feeling a bit older lately too. Feeling like low energy Jeb lately. Like Jeb? I just think of Jeb Bush. She'll have any side effects of those nanobots. Well, yeah, I mean, you're already working on the computer cluster, right? Why not cluster some nanobots? Wait, Jeb Bush in 2016 did something? I don't remember that. I don't remember what Jeb Bush did. Oh yeah, he was like, please clap. That was him, right? I don't. Was that in 2016? That's the only thing I remember about Jeb Bush. Yeah, I'm gonna write that down, Buddha. Skeleton. Sorry, you remind me of a previous chatter named Buddha. 90 trillion nanocluster. Yeah. Very long cylinder. Yeah, that's what I think of too with Jeb Bush. Please laugh. I was talking to my friend the other day. She's really hired a math professor at UT Austin. Something that Maxwell equation have really nice formulation in terms of something called Hodge theory. Okay, interesting. Magnetic field at a point on the axis. Okay, so What does the field of this look like? uh I assume like around the sides it's just gonna be like a straight line, something like that. But what about like we're running it on an axis, and I assume we're gonna have to find it both inside the cylinder and outside the cylinder? Um and so I think like is it worth it to consider a single disk? This feels like a chapter 1 Coulomb's law problem, this type of setup. But like if we figure out just of one of these disks, I assume we could, just multiply through the cylinder for, or like I guess integrate. All right, well, let me make this drawing bigger. Complete the rest of the drawing quick before I get banned on Twitch. Okay. We want to look at the contribution. Of that little bit there. dr rd theta What is this little piece doing for us? It's spinning around in that direction with angular frequency omega. And so what direction is the field going to point? That's what I'm kind of trying to figure out right now. So it should be pointing like up or down, should it not? That's my gut is telling me. Could it be tilted? No. How's this a 2-star? This feels like it's gonna be kind of complicated. Could you consider this a bunch of rings? I feel like, isn't that potentially dangerous? Is there an Ampere's law trick that makes this way easier? I doubt it. I assume you gotta do some disgusting integral with Biot-Savart. Probably making it very long so that you can ignore some sort of approximation that lets you ignore edge effects. That's a good point, Mega, yeah. Um, Seeing the Hodge star operator Base's gauge feels not to gravity. Hmm. It would be nice if we could use like this thing here. But I don't know if they actually calculated that. I don't think they did. Oh, okay. There we go. Hmm. Homology class and differential forms. Hmm. BL should be something with theta hat, right? Because it's always tangential. The length of it is RD theta? I don't know about R. In cylindrical coordinates, I don't know what R is supposed to be. If this is gonna handle it, could it be too bad? Wendy Cepeda, could I please explain multiplication and division in scientific notation? Yeah, sure. So, let's pretend, let's maybe take two big numbers. I'll just make some up. 6.01 times 10. Is this Avogadro's number? I bet you two. It doesn't matter. I'm just going to like times 10 to the 5th or something. I'm going to do 10 to the 23rd. And then let's say we also have 4.52 times 10 to the 7th. If we want to multiply these, so we're given the problem 6.01 times 10 to the 5th times 4.52 times 10 to the 7th. This is all multiplication, so we're allowed to rearrange things. We can do 6.01 times 4.52. So like group the non-tens together and then group the tens. And so this, I mean, ideally I have a little bit easier numbers to do calculations by hand with, but I'll just use the calculator for that part only. 6.01 times 4.52 is 13 point, I'm going to round it at 6.1. There are a couple more decimals, but I'm going to try and keep it to 2 decimals. So that's the first part of the number. After we do these two number times each other. And I'm grouping it like this because 10 to the 5th times 10 to the 7th, if you know the trick, is very easy. Because they have the same base of 10. And so when you have the same base multiplied, you add the exponents. So it'll be 10 to the power of 5 plus 7 is 12. And so this is nearly the answer, but it's not quite inside scientific notation again. We do need to shift the decimal to the left once. But if we do that, and I'm going to make it 1.36 now just to be consistent with 2 decimals. If we do that, we do need to compensate and make it 10 to the 13. If you shift it left, I think you would need to increase your exponent. Yeah. And so we can also divide these two numbers. And it'll be a similar procedure. So if we have 6.01 times 10 to the 5th divided by 4.52 times 10 to the 7th, we'll do a similar grouping where we'll worry about these two numbers in front and then worry about the tens. So I'm going to use a calculator again for the two numbers in front. 6.01 divided by 4.52. We're going to get 1.33 times 10 to the something. So now we have division, and so when you have the same base being divided, you do the subtraction instead. So it's going to be 5 minus 7 is negative 2. And that's already in scientific notation for us. We don't have to worry about the decimal here. And yeah, does that make sense, Wendy? Is there a problem that you would want to see? Okay, no worries. Thank you for the question. Garage numbers, how many moles are under the golf courses in the world? Why is the golf course in Italy? I think I travel around the world to measure that at the time. What is the man? Polar vectors are kind of the worst. And I say they're the worst because I don't things that I don't understand are inherently bad. Is what I'm trying to say with that. Um, do you think polar vectors are bad? You see polar bears? True. And so this mechanics book, I saw it has an explanation for polar vectors, and I wonder if this will be enough for me to understand it quickly. So like the crappy thing about polar vectors is like the base like changes depending on where you are, which seems really unhelpful. Like r hat always points away from the origin. It like whereas x hat just always points right. That's really easy to work with. But all right, that's not a whole lot helpful. Like my issue is that in like I at least for this approach to work, I need to be able to express a vector from here to the point of interest z in terms of cylindrical vectors, and that doesn't seem simple. Now that I look at it, actually, is it minus r zero? Maybe not zero. Maybe it is zero. And why is it minus r? Do I have a reason for And these R's are ambiguous. I'm using R in two different senses. Ugh. Let's call that distance big R. And this in bio sera large R. Now, why am I saying minus R? Because the component of this vector is going towards, yeah, the origin, or it's the z-axis. That might actually do the trick? Question mark? We just need to work out what the current is. Um, so we should know that sigma is equal to rho dz. I is equal to the amount of charge contained in that area times angular velocity, or no, times actual velocity, right? So the amount of charge this thing contains is sigma r d theta can I just multiply by omega and be done with it? That'd be nice. I feel like I can't though. Is it omega times r? But that, I feel like I messed up the units. I won't stop you. You know, thank you, Mega. You have my back. Well, that part. Okay, let me look at the for what they did for the similar problem with the sphere, because that should answer this question. Like the current they work out should apply pretty well. Okay, so to get the actual velocity. Um, And I guess they're just okay with that. Okay. So I think it's just gonna be omega times r. There's a little more complicated because they have a sphere. So, and if sigma is rho dz, we'll get sigma omega r squared dr d theta dz. Taking a course on nonlinear optimization and numerical analysis and whatnot, such an alien subject to me. I've never taken any optimization course before. That's somewhat cool too. Does anyone know a good textbook on the subject? Professor isn't following anything closely, I think. My numerical methods course, I don't think was that advanced. And I don't think we followed a book either, to be honest. It's not a book that I knew of. So I'm not sure personally. This row dz can probably stay on the side though. We're not going to integrate with respect to z for a minute. Do the units check out here? Don't we have like 5 measurements of length? That seems like a potential issue, doesn't it? So that's theta per second. That's meters squared. Meters, coulombs per cubic meter, meters. This is coming out to be coulomb meters squared per second. That seems bad. Do we want it to be coulombs per second? That's charge per area, and that's per second. No, but there is a d theta. I might be okay. Oh, no, d theta isn't, oh yeah, so I did that. D theta isn't meters. Get rid of that. That solves part of the issue. I don't know, this feels right to me though. Is DL the one-dimensional length? I should make sure of that. Oh, they kind of do DL separately. I mean, can we just do the same thing though? Can we just say that it's going to integrate to 2 pi r? Um, I'm probably doing it the hard way relative to how the book is going to do it, but what do we get out of this cross product? Let me delete this. Is the cross product the same in non-Cartesian coordinates? I didn't even think about that. I'm gonna be honest, I think I bit off more than I can chew with this. Um, I think I should probably just handle the vector stuff separately to like figure out what direction. Oh, really, Mega? All right. I mean, yeah, we can just like do the calculation and see what happens. It's probably easier to just work out the vectors physically. Yeah, I'm slicing it into disks, and then I'm slicing the disks into little squares. Should I just go straight to slicing them into rings though? That might be the that's probably the answer. Just slice them into rings. I'm curious if I still want to look at this cross product just to see if I get anything that looks interesting. Um, this seems like it's zero. No, maybe it's not. Oh no, no. We're gonna get uh our hat is gonna be RZD theta. What am I doing? Okay, that doesn't mean anything to me, I'm gonna be honest. Um, well, yeah, so like one difference between the spheres that the sphere was a shell and this is solid. Um, but it does feel, man, I really want to use the field due to a ring, but that's what messed us up the last time, right? with the sphere. The the book just did the spheres from scratch, and I was trying to do this from scratch. But this is really hard to do from scratch, as it turns out. Does some of you feel like it could work? You know what? You've been on point, Fembox. Uh, see. What's the field do to a ring? And we can take it at the center of the ring pretty safely. So mu naught I over 2b. Is the formula the book provides. And b is... Oh, no. Field on the axis. No. We don't get off that easy. Mu naught IB squared two b squared plus z squared to the 3 over 2. And b is the radius of the ring. My small r is their b. Our z's are the same. Now the current does depend on r, right? If we do this setup, I think the same formula might still apply. So the area is r d theta multiplied by sigma, multiply the velocity, I mean, we know theta is going to be from 0 to 2 pi. Can't we just integrate that right now? And this feels right? Potentially? Is that annoying? Yes. Can I do it? Maybe. That's a weird integral to get though. If that's provided in the table, we'll go with it. I feel like I have too many r's in the numerator though. Surely. Yeah, they don't have this in the table. What does Wolfram Alpha think of it? Arcsench? That's not as disgusting as I thought it'd be. It still just feels like a lot of R's though. Let's just use the Wolfram Alpha result. I don't feel ashamed of that. Because I kind of I feel like I need the R's that I have, so how does that look, by the way? Well, I don't know. There's no way it's supposed to be this complicated. I just don't think they do some ridiculous stuff. I don't think they do stuff that's that ridiculous. It is a squared, by the way. I messed that piece up, but I don't know. I'm kind of tempted to just like say I probably shouldn't have started a problem this hard, right? Like towards the end of the stream, and call it. I feel like for part B, it's gonna be more or less a solenoid with a very well. The field for a solenoid diverges, so I don't know. If you let n go to infinity. I don't know. I think we're just gonna call it for the day, to be honest. Uh yeah, let's call it. Gonna cut the YouTube stream off here, so anybody's here on YouTube, thank you. back on YouTube probably on Tuesday.